All right, 1, 2. All right, what's up, everybody? Welcome to Jupiter Brain. So we had a little bit of technical difficulties. Been having technical difficulties, and so we just wanted to explain that really quick, and also just have an introduction. Because if not, we wouldn't have had an introduction because it got cut off, unfortunately. Not really sure how, but it did. And so yeah, you want to explain the cosmology episode
Oh yes.
issue?
So in a little bit, the actual video will start. But basically, we have 3 little things to announce before the actual video goes on.
Mhm.
First of all, the cosmology video also has technical issues. It's been corrupted and deleted. And so we're gonna make a new cosmology part 2 video someday in the future.
Hopefully we can
down
get
the
it
line.
back, but
Yes.
it's looking like we're not going to be able to get it
Yeah,
back.
it's leaning on the less probable side. And then the second thing is fall break. I'll be out station. I'll be in New York because of document stuff. And also it's a holiday. We won't be able to have access to a lot of facilities. And third is Halloween week, which is also a holiday. We will not be making episodes on these 2 days.
And I'll be out of town. I'm going to Palm Beach, Florida for a conference. So wish me luck.
Yes.
And so is that everything?
Yeah, that should be everything. And so we'll hope to see you guys in the episode from the future.
Yes.
All right, ready?
So yeah.
Until later.
Yeah. And so here's Prather and us talking about what we did on the podcast.
Yes. Inferential dynamics.
Yes. There we go.
Right.
There, I think it was like 10:30, and the guy was like, I think someone else has booked it, and I was like, really? And so it would kind of be funny if we went down there right now and it was actually us that booked it. But at the same time, though, we've been wanting to try this room out.
Yeah.
So it's just kind of like a happy mistake.
Sometimes that's how progress happens.
Yeah, exactly. And so yeah, I guess we're going to be filling out this room. And what's nice is it feels more roomy.
Yeah, there's more room to move around.
I like the bricks and the natural lighting.
More space
and things like that. But yeah, so
more room for the Jupiter brain.
Yeah. So here at Jupiter Brain, we like to say that we are engineers by day, philosophers by night, and today we're going to be philosophers during the day.
All right.
Because I believe a lot of what your talk was over, and this sort of new formulaic way of getting to the truth is it feels very, in some ways, philosophical.
Yeah.
And I think any conversation about truth feels very philosophical. You're right. You start to think of those truths or thoughts and things that you don't feel like you can grasp the truth of.
Yeah.
Right? Like, for instance, like the beginning of time. When was the beginning of time? Right. And you're like, well, we don't have like a tangible place that we can just, hop in a spaceship and go and say, all right, this is the beginning, right?
Yeah.
And so yeah, we're excited to get into that. But, we like to start up every podcast with sort of how our week has gone. And so I don't know if maybe we'll talk about our week, but we definitely want to know like about how your week went.
You want me to start?
Yeah.
Okay. Well, man, I've had a busy week.
Yeah.
So this week on Tuesday through Thursday, they had Innovation Week at the Science Museum.
Yes.
And so over the weekend, I was working on getting my pendulum project brought up to speed. I kind of think about it in 3 phases. You usually have a prototyping speed. You have a kind of a demo. Right. I have a prototype, and then I have a demo. And then I usually have some kind of, final product.
Yeah.
And so at my old job, we used to call these MVPs, minimum viable products.
Okay.
And so over the weekend, since this is going to the Science Museum, right, I wanted it to be kind of like trade show ready, if you will.
Yeah.
Right? Not a finished project you buy off the shelf, but not a prototype with wires all over the place.
Yeah. I got to see this prototype.
Did you?
It looks great. Yeah, you came by.
Oh, I walked by. Well, yes, that's right. Yeah, because I remember I walked by it. I think at that point it was.
Was it the
I showed you at work.
episode?
No, this was earlier in the week. I think it was Monday, right? I think it was Monday.
Yeah, something like that.
Yeah, well, I know. So Saturday night at probably a good 1:30 in the morning, and I was like, okay, all Saturday I'm just gonna get this thing working, right? Get it tested, make sure everything's gonna go smoothly because it's going to be at the Science Museum for 3 days.
Okay.
And I'm not going to be there.
Bunch of kids grabbing it and pulling it apart.
Over, I think it was like 1,500 kids.
Oh my gosh.
It was awesome.
Wow.
So I think there were about 500 each day that just kind of walked by into this thing. So basically, over the weekend, I thought, okay, I got to bring it up to speed, make sure it's going to work, right? Go through some testing procedures. So on Saturday, my focus was just to make sure that I had the mechanical and electrical build. And then Sunday, I was going to do some kind of shock testing, right? Kind of see how far I could throttle it, what I could do with it. What are the boundary conditions, if you will. Unfortunately, Saturday about 1:30 in the morning, I realized, I mean, it's late. Sometimes you make stupid mistakes.
Yeah.
I seem to work better at night for some reason, but at the same time, sometimes you make little mistakes. Well, anyway, long story short, my whole circuit fried.
No way.
Yeah. So I used to have a bench power supply that was just running the circuit, running the propeller. But I was like, oh, I'll get a nice little AC/DC converter, slap that on there, put a nice lamp cord on it so it plugs into the wall, looks really professional.
Yeah.
Okay, so I had that all set up, put a little switch on it, hit the switch, the red light didn't come on. And I was like, well, so the thing is, I should have prefaced this. The switch that I had comes after the AC/DC conversion. So it plugs into the wall, get 110 volts, whatever. Out pops 5 volts DC. From there, I had a switch to the board, so I could turn that on and off. But the red light on the AC/DC converter should always be on, whether my switch is on or not. Well, I was hitting the switch, and it wasn't turning on at all. And I looked at it, and I thought, oh, no.
Yeah.
So I'm missing some steps. It's really not that big of a deal, but I'm testing my sensors, again, late at night, trying to put the whole thing together. Before I plugged in the power supply to the wall, I tested the circuit, the sensors, everything was beautiful. I mean, beautiful. I thought, okay, we'll plug it in, test the propeller, make sure everything behaves appropriately. I plug it in, and immediately my magnetic encoder, the position of the pendulum, became erratic, the signal. And I was like, oh no, okay, so I can fix this, right?
Yeah.
Okay, I'll plug it. I'll try to test it, plug it back in, see if it works. Well, I had all these wires all over the place. And I thought, and this is just a thought, I don't know if this is what happened. Because there's a whole bunch of wires running past an inductor on that AC/DC converter, I thought maybe the magnetic field is somehow influencing the signal. So I thought, okay, well, I'll redo my wires, clean it up, make sure they're not, right next to this inductor.
Solving problems under duress. I love it.
At 2 in the morning.
That's crazy.
And I'm sitting there, okay, let's fix this, let's do that. Well, I fixed the wires, clean them up, make them good, but now my sensor doesn't work at all.
Oh my God.
And I thought, okay, well, it just works. So it's not that the wiring is bad, right? Unless I've made a simple wiring mistake. Well, come to find out that switch, when the red light didn't come on, basically overloaded both of my sensors. So the sensors just fried. So it's like 2:30, 3 in the morning.
Yeah.
And I'm like, okay, this has to be done on Monday. This is Sunday morning, right? 3 in the morning. And I was like, this has to be done Monday by 10. And I was like, okay, well, I can't go back and buy a new AC/DC converter. I can't make it all fit, so I have to come up with a contingency plan. I always have a backup plan.
Yeah. No sleep for the wicked.
Pretty much. But I realized that's like, well, okay, I don't really need to use this fancy AC/DC converter. I'll just use the bench power supply, send them to the Science Museum with just some stick on the bench, plug it in, manually control the voltage, easy.
Yeah.
So kind of re-rigged that. That worked. But my thought process was, okay, I don't have enough time to stay up and fix it. I'm just going to come up with a plan so that when I wake up, I know what I'm going to do.
Yeah.
So I woke up the next day, kind of, calmed down a little bit because I was upset.
Sleep on it.
Oh yeah. So I woke up, ripped the whole thing apart. I had this really nice cable harness that I had made. So I was hoping it wasn't that. It wasn't. But I went to the school because I didn't have an extra sensor. I had to replace both the accelerometer and the magnetic encoder. So I went to the school, got some more, went home, resoldered them, put them on, put it back in, tested it. Sensors worked. Plugged in the power supply, did the switch the right way. Everything worked. And by probably 3:45 Sunday afternoon, it was working. And I was like, I actually didn't think it was going to work. I was saying, I'm probably going to end up disappointing somebody because they had been planning on this event for a long time. And I obviously had the pressure of like, this is going to be the thing that they're taking to the Science Museum with them. And so, for one reason or another, I was able to figure it out. So that was my weekend. And then Monday, I was getting ready for the talk on Tuesday. And then we've got some stuff going on in the School of Engineering with ABET assessment. So I've been working on getting ABET assessment tools and other things like that. So, obviously my standard work. But on top of that, getting ready for the talk and getting this pendulum ready were kind of the biggest things I had to get over.
Yeah,
So
that's
yeah, it's
awesome.
been a busy week, but
So-
very productive and satisfying.
The meeting that you had today, was that for ABET or?
That was for ABET, but it wasn't the ABET meeting. We just had our monthly School of Engineering meeting. So that's where I was
see.
and got my free food and
I see.
did that at 12:30 so I could be here.
Nice. Can you unveil like what all you guys talk about in that meeting? Or?
I'm sure there's some things I could or couldn't say, but I
Yeah.
don't really think any of it matters.
Yeah.
At least
Oh, okay.
anything that you'd care about.
Okay.
Honestly, it's a lot of, what kind of questions are they going to ask, or what things
Yeah.
are they concerned about, or what things should we be concerned about,
Yeah.
or are we in good footing, or what? There's really nothing. It's very bureaucratic, so there's really
Okay.
nothing exciting or
Gotcha. Yeah, because I know
nothing that I could reveal that would be neat.
they wanted students to be here this morning at 9, I guess, to go over some things.
Yep, there was a meeting with Dr. Hassan this morning with some of the
Yeah.
students.
I
So I
wasn't
think
able to make
what
it.
ABET will do is they will meet one-on-one with faculty.
Mm-hmm.
They'll basically take a tour of the campus, or the campus, our specific side of campus. And then they'll meet with some students as well to just
Mm-hmm.
kind of get some feedback about, how our program is doing, how the school's doing, what we're doing good, what we're not doing good, how we can improve.
Yeah.
So I look at it more, and you guys know from the talk, right? For me, negative feedback is important.
Yes.
Right? Just saying, it's all going to go great. I think, of course, ideally, there's no problems. But it's kind of delusional to think that there won't be problems.
Yeah.
Thinking.
Yeah, and so I think what we're doing is we're really just trying to make sure that we're prepared for the things that we need to improve on, and I think that's always a good idea.
Nice.
So almost anticipating negative feedback,
Yeah.
so that we can converge to a stable system and continue improving.
Of course. And so have you heard of any, I guess, I don't know, anything more about the computer engineering
Yeah, well, I
accreditation?
don't. For me personally, I'm not really seeing a whole lot of that side. I'm just hearing about it.
Yeah.
So this will be, as far as everything goes to plan, the first accredited computer engineering thing that we've had. We have it on book. It's not officially accredited, but from what I understand, and don't quote me on this, but I think this is how I understand it. Once it's accredited, it is retroactively accredited. So anybody who started the program, I think in 2019 is when the program started. We had one person and they just graduated last year. They will be retroactively accredited because that was part of our last 6-year review process. So other than that, I don't really know. But I, from what I understand, that will be the newest addition to the accredited programs that we offer.
That's awesome. Heck yeah. That's a win for UCO for sure.
Well, and if you go look at the enrollment numbers for computer engineering, I mean, it's just
Keeps going up, huh?
yeah.
Interesting. Yeah. I guess I haven't met any freshmen. I know it's like me, Colton, and a few other people. Because like whenever I first started here at UCO, I couldn't find any computer engineers. And
Well, I know some people are switching from what I hear in the meeting. Some people are switching from software. What is it?
Computer science.
Computer science into computer engineering. So we're pulling some people over, which is good.
I mean, I don't know. For me, it's all about job opportunity, right? And so just having a degree of computer science sort of limits you, where if you have a computer engineering, I feel like you can have more of a...
Yeah, I'd say you're probably more technically inclined.
Yeah.
Or you have a little more technical background.
Yeah, and then you can, have more of a broad paintbrush when you go to find a job, right? You can be,
Well, I think the biggest thing is
or-
having the ABET accreditation, right? So if you get a computer science degree, I think that it's just it's a degree, it's a science degree, but I don't believe computer science is ABET accredited like it would be if you were talking about computer engineering.
Oh.
And so that I think alone, on top of it, even if it was unaccredited, right? Computer engineering I think would still stand out compared to computer science, is more technical. But adding the ABET accreditation on top of that makes it a lot more leverageable and compelling.
Yeah, wait, so computer science isn't accredited?
Because ABET's for engineering.
ABET's for engineering. I mean, as far as I understand,
that's
ABET
right.
is Accreditation Board for Engineering Technologies. So maybe computer science is involved there, but I think kind of
Maybe they just have a different...
The separation is that there's computer science and computer engineering, and we're trying to keep them separate.
Okay.
Trying to really emphasize what computer engineering does differently and uniquely to computer science. So that's something new coming down the pipeline.
Yeah, interesting. Cool. Yeah, it's always fun and exciting to hear that UCO we just keep progressing. It seems
we're
like.
growing.
Yeah, I love it.
Maybe too fast. I say not in a bad way, but it's hard for all of us faculty to keep up.
Apparently, computer science is accredited by
Is that right?
Accreditation Commission of ABET.
Okay. Well, because I was going to say that computer
so
science.
they have a separate accreditation. It's still accredited.
I see.
It's not the EAC, the Engineering Accreditation Committee, is it?
It's CAC.
CAC. So they have a computer accreditation committee.
Yes.
So it's just similar, probably under the same
It's
house,
under ABET,
but it's a different group,
for sure.
different committee.
Well, because one day we were just in the lab, and Matthew Goodman, he was interested to see like what was the highest, I want to say, population of degrees.
Of all the degrees.
Yeah. And computer science is from. If I can remember right, it had the most people enrolled in.
I know they have a big program.
Yeah, it was like 600 something.
No
something
way.
crazy. Yeah.
Maybe like total enrollment, right?
Yeah.
Because I think what we do is we do it by freshman enrollment and then graduates. So if you go to, as far as I know right now, if you go to UCO's engineering website, you can go down to all the different programs and click on them, and they will show you, I believe it's enrollment and then graduates. So how many people graduated last spring or fall?
Yeah.
And then how many people are, I believe, enrolled in the program. I'm not sure if that's just, because I think mechanical engineering is 180, 190, somewhere around in there.
Okay.
Electrical's 160, 70, 80.
Yeah.
Physics is like, I'm a physics guy, so it sounds low. It's 30 somewhere, but it's been the most consistent.
Engineering physics, you mean?
Engineering physics.
Okay.
Yeah. I don't know all the other ones, but yeah, I think 600 sounds like a lot.
It does. I think it was like 300 to 600, something like that.
Yeah.
If I can remember right. I don't know. I don't have to pull it up. But
Jamie, pull that up.
Yeah, please. I wish.
But nonetheless, right, lots
Yeah.
of growth in both sides. Yeah. So didn't know that they were accredited. That's cool.
Cool. So, Albert, anything stick out in your week?
Nothing. It's just been quizzes and homework. This
Nice. Well,
Classic.
Fall break's coming up though.
what I was going to
Finally.
say is we are in week 8, right? This is the end of week 8. We're halfway through the semester.
Which is crazy. That means we made like, how many episodes have we?
This is not in the 9th episode.
That's crazy.
Oh, you've been doing one a week?
Yeah.
I did not expect that. That's kind of fast.
Yeah, and so what we were thinking is like maybe like the last episode of the semester, right? We go over all the different things that we've learned.
Like a kind of a
Summary.
Yes.
anthology.
Yeah.
We were even thinking of maybe like doing a live podcast or something like that.
Yeah.
I think that'd be really fun.
That would be cool.
Yeah.
Like a mini panel type thing.
Yeah, exactly. Maybe have a guest on or something like that.
Yeah.
Just introducing the idea to you.
Okay. Warming me up to the idea.
But anyways, my week was just, I don't know, just I guess excited that we're finally in week 8 and just trying to, I don't know, mentally prepare for the rest of the rest
It's
of
weird.
it.
You go on fall break and you get the little tease of what Thursday, Friday, and you're off.
Yeah.
And then you come back and the semester ends. I mean, you have Thanksgiving break, and then you come back. I think it's like 1 week and then finals. So after fall break, I mean, it's just hopefully downhill.
Yeah.
I'm sure there's some uphill battles.
There's still going to be some
with exams
resistance, right? Like a rock in the way or a
Oh,
boulder.
But it's weird. I think spring's different because you go to spring break, you get a full week, you come back, you feel hopefully rejuvenated. The fall break just feels like a tease, and then you're waiting till Thanksgiving, and then by the time Thanksgiving gets, well, the semester's over.
Yes.
So it's fall flies by so fast.
Yeah.
It's strange.
It does.
And I love the temperature change.
I was about to say, I think a lot of that has to do with the temperature and the sun dropping earlier, right? So the sun, I think, would stay up until 8:15 during the summer, and then it's slowly 7:30, 7:15. I think tonight it'll probably set at 7.
Yeah.
I mean, I could look at my phone.
Are you? What's your favorite season? Is like you a summer or a winter guy?
I
or
love fall.
Fall? Yeah.
I don't
Fall's
know.
a lot of people.
I like winter.
Yeah.
There's a snowboard brand called Never Winter.
Okay.
Or, I'm sorry, Never Summer.
Okay,
it's,
I'm about
it's
to
a
say
winter
that would be-
brand. Yeah, it's a winter brand.
I see.
So I always like bundling up, putting on some like big puffy clothes.
Yeah, I was.
Layering up, you can take layers off, but in the summer you can't. take layers off if your skin's always
Yeah, I don't know. I'm conflicted. I love the summer just because, I don't know, I hate like studying or whatever and like shivering and I'm cold, you know?
Yeah, you don't want to reach out to your
I'd rather
computer.
be
You just
warm
stay
and
right
feel
tucked up.
loose and
Yeah,
like,
that's
let's
fair.
go.
Yeah. I can tolerate the cold more than I can tolerate the heat.
Okay.
Yeah.
Nice.
You know, you can't stand the heat, get out of the kitchen. Well, if it's cold, just turn the heat up.
It's true.
Put more layers on. Yeah, I was born in a blizzard. Yeah, so.
Really?
Yeah, February 12th, 1993. That's my birthday. There was,
that makes sense
a blizzard. And
How I'm imagining you was like
cold-blooded.
being born in like some part of Scandinavia.
Maybe that's why
I'm sure my
you like
Welsh
to snowboard.
blood would have a little bit to say about that. Yeah.
Yeah.
The high north.
high north cold.
I like the cold.
Heck yeah. And maybe that's why you like to snowboard.
Oh yeah, absolutely.
Yeah, I know. I've been watching videos of like people skiing and snowboarding. I'm like, oh, come on.
I know. One more semester.
Yeah. Are you going to be going?
Hopefully next spring break. Yeah.
Okay.
Yeah.
Nice. Heck
Yeah.
yeah.
At least this fall break, I'm not doing anything.
Yeah.
We have ABET coming up, so I will be doing stuff. But
Yeah.
I don't have. Sometimes you go on vacation, you need a vacation from your vacation. Well,
Yeah.
I'm not doing anything.
Yeah.
Taking Thursday, Friday off.
Well, it's funny, I will sometimes say, I'm not doing anything this weekend. I'm just going to make sure to just clear out my mind and whatever. But in the back of my mind, I'm like, well, I do need to do a little bit of that
work on this a little
homework.
bit,
And, so I just won't be, pedal to the metal,
Yeah, I mean, you still got to throttle it a little bit.
Yeah.
Keep the momentum going.
For
Because
sure.
otherwise, I think,
You stall.
Newton's third law.
Yeah.
Well, I guess the first law, the law of inertia. Yeah.
Wait, I just have a quick question. After thinking about all the ABET stuff, do you think we'll ever have a chance to have a theoretical physics?
It's funny you say that. Dr. Ayat Musa is talking about trying to introduce concentrations to the engineering physics. This is probably insider knowledge. But anyway, with biomedical engineering, there are 3 concentrations, and I won't act like I know all of them, but one of them is instrumentation, one of them is something else, and something has to do with biomechanics. Well, in physics, it's proposed that we have another concentration, or we take the engineering physics and separate into concentrations, with one of them being like electromechanical, so kind of a focus on electricity and magnetism, and then also a mechanical component of that. Obviously, motors are electromechanical. The other one I propose would be theoretical. And so you kind of have a practical engineering physics and a theoretical engineering physics.
That would be awesome.
And for me, as a student here, I thought I was more of a kind of a theoretical kind of perspective.
More
And
of
then
a Oppenheimer.
Maybe, but as I did my thesis, I realized I'm much more of an experimentalist.
Oh.
Because if I can't test it, touch it, feel it, see it, show it, demonstrate it, doesn't really matter. You can have the idea and show that proof of concept, theoretically, mathematically, abstract, whatever. But unless I can demonstrate it, because I've been so onto Euclid's elements, right? The idea of proof by demonstration, right? Quod erat demonstratum, QED. Being able to show something by demonstration, I think, is much more compelling than a theoretical proposition.
True. I mean, Oppenheimer proved it by making an atomic bomb.
I actually have a tab pulled up of Oppenheimer versus Heisenberg, so I'm going to watch that this weekend.
That'll be awesome.
Yeah.
I need to watch that.
You said you're going to watch what?
It's a documentary of kind of Oppenheimer versus
Heisenberg.
Heisenberg. Yeah.
Oh,
Because they're both one on the German side, one on the American side, trying to build the atomic bomb.
Yeah.
Okay, is this on YouTube somewhere?
Yeah, just on YouTube. Yeah, I don't know I'm sure there are several of these.
Okay.
If anybody's looking for some fun, I love me some documentaries.
Yes.
Timeline on YouTube, they have lots of good documentaries.
Well, I just, speaking of documentaries, I just watched one the other day that was about bird watching. But it's like oh man, I gotta look this up. But so these guys, I guess they're just documentarians, and I've been wanting to look at what else that they've gotten into in their YouTube channel. But they did what's called the big year in bird watching, and so essentially you spend like the whole year trying to identify as many birds as you can, and you have to like take pictures of them. And
it's like a yearly scavenger hunt. Right?
Yeah. But what you find out is that the bird watching community is like really stringent. Really, they want you to adhere to very stringent rules and guidelines. Yeah, and so these guys sort of came across that, and there was like some birds that got taken away from their
they're kind of coming
observations.
at it from the outside.
Yeah.
Oh, okay.
And my girlfriend is a huge into, not necessarily huge into bird watching, but it's like a new thing that she's come across.
Yeah.
And I've it's rubbed off on me a bit. And like there's this app that you can just press play and put out in your backyard.
Sounds,
and it tells you all the birds. And so I've been wanting to make one of these for her. But it uses machine learning to identify all of these
just signal
bird
processing.
sounds.
But you get all the samples then.
Right.
Yeah.
But I'm just curious. So like this ornithology, right? Study of birds. I feel like do you think they make like? I'm just curious. Do they make a lot of money?
Oh, probably not.
I feel like maybe I'm wrong, but I can't imagine there's a lot of lucrative research there. I'm sure it's useful.
I bet there's some people that do. I bet like there's, because there's a lot of people that are into this, right? So I'm sure like
feels more
content
like a hobby
makers,
type,
YouTube, I bet they make it, decent.
I'm just sort of wondering where the source of income would be from.
Yeah, I don't know.
Software development.
Listers. That's what the I guess what the like technical term for bird watchers is listers. And if you just like go to YouTube and look up listers, A Glimpse into Extreme Bird Watching is the documentary. It is really like a really well done documentary. And I don't know, I just always love when people like jump into something like wholeheartedly and don't really, I'm gonna say, like they just have like their curiosity that they're bringing to the table.
Passion.
There's a quote from Feynman, and you'd probably pull it up because I'll butcher it a little bit. But paraphrasing, it says something about find whatever it is that you're interested in and study it. Just pull it up because I'd rather you read it. It's about studying and irreverence.
Okay, studying in irreverence.
Yeah.
If I can spell irreverence. Irreverence. I got, let's see here. I'm sure it's going to pull up like 35 of them.
There's one in particular.
Study hard what interests you the most in the most undisciplined, irreverent, and original manner possible.
Yep.
Richard P. Feynman. Interesting.
Great quote.
Yes.
Because there's a level of kind of anti-dogma that I think he has and brings to it, right? Of, I want to study what I want from my own perspective.
Yes.
And I'm not going to be reverent to some pre-existing dogma that exists. And I'm going to do this originally and with my own perspective.
Yes.
And that's kind of what you're saying about this is somebody bringing in, that's not their field, but they're interested and they're passionate about it. And they bring something, it's called beginner's luck, right? Sometimes it's the newbie gains. Sometimes you have a different perspective as an outsider. But people who have been so inundated in the field for however long don't see it that way. They can't because they've almost occluded that almost intentionally. And so they say, what this thing? And you're like, well, no, we don't worry about that. It's like, well, but why not?
Yeah.
And then all of a sudden this whole thing opens up.
Yeah. Well, that's why I say go, if you're someone who enjoys that sort of, I don't know, outlook, I guess you would say, go watch that documentary because there's a lot of like lessons that we would all learn if we did something kind of like that as well about I don't know, a new topic or whatever. And so I don't know, it's and just for me, I just like I'm like a dog with a squirrel, right? Like that's how I like seem to like move throughout the world. Is a new topic or something I haven't heard of before like pops up
and you want to chase it
I'm
down.
like, oh, squirrel. And like I just end up going down the squirrel hole, the rabbit hole, right? And yeah, that's just how I don't know, to me it's, I don't know, I just love finding new things to learn. And to me, that's knowledge is exciting. What makes the world sort of exciting, and I think it's a good way to sort of get into the topic, the meat and potatoes of today, which is your talk over, and so I guess just inferential dynamics, truth as a stable attractor of reason. Hello, space travelers. Want to look sharp while bending space-time? We've got brand new Physics Society t-shirts. The clean graphic tee is just $20, and if you want to drop some Einstein-level wisdom on the back with this quote, "I have no special talents, I'm only passionately curious," that one's only $25. Rep your curiosity, rep the cosmos, and support the Physics Society. Grab yours today before entropy takes over. Is what you titled your
Working
presentation.
title.
Working title. Yeah.
I've actually changed it probably 20 times.
Really? Nice. We were talking about that in like senior design.
Yeah.
How like we're always changing the name.
Well, because at first there's a, what's the right word? You have a general view, a general scope of what you're going to do. And then as you start to dive into it deeper, your brain compartmentalizes how those things interact with each other, and you start to kind of reframe the question and
To a better one.
right? You almost converge on a more critical description.
Converging on truth.
Yeah, exactly. It's weird how it all comes together. But I think, you spend a year on a senior design project, and by the time you're done, the name you started with, you almost hate. Because you're like, this isn't good enough. It doesn't describe what I'm actually trying to do. So with inferential dynamics, that like I wrote that probably an hour before I gave the talk.
Nice.
Because dynamics of truth, dynamics of reason, dynamics of logic, inferential dynamics, it just kind of, I don't know, it just kind of came to me, and I thought, well, that's the best way to draw with it. There wasn't
That
any
makes sense, though.
special.
I do like it a lot.
Yeah, because it's the dynamics of inference. But as far as I understand, that's something that I think might be new.
Okay, cool. So do you want to sort of maybe unpack some of these things and sort of talk about?
Do you want me to just kind of re-give the spiel? I won't do the whole talk, of course. Since you have the slides, if you want to maybe ask particular questions, but just as an overview, if I were to just summarize it as quickly as I could. The idea is that in logic and inference, there are four modes, at least four kind of canonical modes. There are deeper versions of inference, but at its surface, there are logical sound arguments and fallacious arguments. And there's modus ponens and modus tollens. Modus ponens is arguing for sufficiency. So, right, if it rains, the ground is wet. Well, there are other things that could make the ground wet. So just because I observe the ground being wet doesn't necessarily mean that it rains, right? So it could have been something else. So modus ponens would argue for something being sufficient. Modus tollens would argue for necessity, right? The only way the roof and the ground could be wet is if it rained, right? The sprinkler system wouldn't make, I'm saying only, that maybe somebody in the audience could come up with some other example where the roof could be wet and the ground could be wet, and it could be something from other than rain. Snow would be an example. But the idea is you're arguing from a state of sufficiency or necessity. And the claim is that sufficiency is just that. It's just sufficient. It isn't a one-shot, right? If I can argue for necessity, well, then I have a very critical argument. But the other two, the kind of fallacious arguments, are called denying the antecedent and affirming the consequent. And so if I said, if it rains, then the ground would be wet, affirming the consequent would say, well, the ground's wet, it rained. It's like, well, no, that's not what happened. Maybe sufficiently, but not necessarily. And then the other side of that would be denying the antecedent of saying, well, if it rained, the ground would be wet. And you say, well, it didn't rain. It's like, well, okay, that's not, I'm just saying if it did, the ground would be wet. And you're saying, well, it didn't rain. I'm not saying it rained. I'm saying if it did rain, the ground would be wet. And so there's this kind of, those are fallacious arguments, right? Denying the antecedent is basically confirming the thing you want to be happening. The thing you want out of it must have been caused by this, not necessarily. And then the other one is saying, well, if it rained, it's wet. Well, it didn't rain. You're basically just saying, nuh-uh. Right? It's like, well, you're not even, what's the word I'm looking for? You're not even trying to consider my hypothesis. You're just saying, well, that hypothesis couldn't happen. And I'm saying, but if it did, right? I'm not saying it did. I'm just saying if it did. And a lot of people it can be easy to reject something by saying, well, that will never happen. It's like, I'm not saying it did. I'm just saying if it did, then this would happen. And that's, I think, kind of the logical paradigm that I'm trying to operate in is that there's modus ponens and modus tollens. These are both logically sound, but modus tollens argues necessity, and it's stronger than modus ponens. Denying the antecedent and affirming the consequent are logical fallacies. And the idea is that if you prosecute an argument or a hypothesis or a question by modus ponens or modus tollens, you can converge on a correct. I put correct in quotes, by the way. Sometimes there's no such thing as the right answer. But you can converge on a more stable or more sufficiently necessary claim that if it rained, the ground would be wet. I think it's a reasonable claim. If it actually did rain. And then the other two, right? If I were to argue AC or DA, the denying the antecedent or affirming the consequent, these would diverge from truth, right? They wouldn't do any justice of getting me closer to what it is that I'm trying to find, the question that I'm asking, the probative thing that I'm after. It would actually take me further away from it because I'm actually almost lying to myself or lying to whatever you want to think of. I say lying is maybe not the best word. You're misguiding or misleading the trajectory of inquisition, right? If I have a line of reasoning or a prosecutorial path, and I say, I want to question this claim, don't question it with fallacy, because then a fallacy can be true, but that doesn't say that the claim is true. Right? So the point is I want to argue necessity. I can argue sufficiency, and that is just that, it's sufficient. But necessity it trumps all. If I can prove that something is necessary, if it rained, the ground is wet, isn't really necessary. I mean, it is. The ground would, of course, be wet if it rained. But that's not the only thing I need to do to check that it rained. If I check the ground and I'd say, yeah, the ground's wet, it rained, well, there could have been something else. So I have to go look at what I called in my talk orthogonal vectors by saying, okay, well, if the ground is wet, what's orthogonal to the ground? The roof, the radar. I could go check, I'm trying to think of something else that I could go look at. Maybe I'd go look at the top of my mailbox. I could look at the roof of my car, right? Maybe the roof of the car, the roof of the house are parallel arguments, not necessarily orthogonal. But the idea is you want to change your perspective so that if this happened, these two outcomes must have happened. So if I go observe them and one of them is true and the other one's not, well, then it might be sufficient that my claim results in the ground being wet. But it isn't necessary that that's what comes out of it. So anyway, long story short, there are these four modes of logical inference. I was reading Maxwell's on governors. He wrote a paper on the first linearized system of the closed loop form of a governor system, a closed loop control system. This governor controls the steam, the valve on a steam engine, so it'll control the speed of a train. And they've used these long before Maxwell. I say long before, but sufficiently long that they know how they work. But Maxwell proposed a linearized closed-loop solution that mathematically described the function or the behavior of these machines, these apparatuses. In his paper, he mentioned four modes of motion, four types of motion. And I kind of recognize those four types of motion almost as an analogy to the four modes of inference. There is stable convergence. There is kind of monotonic or polytonic convergence. So something monotonic meaning it just has one form, one wave, one signal. But you could also have aperiodic, right? So I can have a waveform that converges. I can have a damped signal that doesn't really have a period, so to speak, because the wave function collapses, if you will. You want to use that quantum term, not really the same thing, but it reaches a steady state. It reaches a steady state, and you can't tell that there's really a period involved, an oscillatory period. But anyway, these four types of motion analogously kind of mapped out the four modes of inference. And I thought, well, that's interesting. So you can actually take those modes of motion and treat them like how you would divergence and curl. All right, if you think about divergence, you guys know the divergence and curl, right? Maxwell's equations. That's why I think it's relevant. Maxwell's on governors can be mapped to an extent to his four equations of electromagnetism. And so with Maxwell's equations, you have the divergence and the curl equations. They basically describe charge as a source of the electric field So if you were to plot a charge, right, as the center or the origin, the electromagnetic field, the electric field, just the electrostatic field, emanates linearly away from the charge as just straight lines radiating outwards. But the magnetic field is rotational. So it's a curl, not a divergence. You can also map the divergence of the magnetic field, but it's zero because we don't know if there's a monopole. We assume that it's dipolar. So the idea is that there's these curl, the curl, the rotational, and then the divergence, the dot product. So you have dot product, divergence, curl, cross product, right? And those both represented those forms of motion. I thought, wow, man, like if the modes of inference and the modes of motion are analogous, if that's my claim, if they are analogous, then I should be able to express logical inference, not just as a series of questions, but actually as a matrix, kind of as a convergent dynamical system. Not necessarily convergent either, but just as a dynamical system with some particular cases that could converge. Well, which cases would produce convergence? Well, ones that have negative feedback, that remove options, or in the case of a dynamical system, removing energy from a system, right? For my oscillator, whatever you want to think of it as an LRC circuit, you could think of it as a suspension system, spring mass damper, could be a pendulum. You guys know about pendulums, whatever you want it to be. In order for that system to converge, it has to have energy removed from it. I could add energy to it and it could diverge. But the idea is in a logical state, a logical system, right? I'm not necessarily removing energy, but information is energy. So by removing information, the analogy to energy, it's like removing options. So, process of elimination, right? It's not this, it's not this, it's not this. It must be this, right? It's not saying it is, but that's the only possibility that remains. And so deduction is akin to modus tollens, saying basically treating it by necessity. It isn't this, it's not this, it's not this. It must necessarily be this. And so removing energy, removing options, removing information from the system brings it to a convergent system. Not that, oh, that's the truth, but this is the thing that is most likely to be true. So anyway, just treating kind of those two things as analogous, that there's a mode of inference and a mode of motion. And inference, logical inference, is really just a form of motion of information. Right? It's how does information propagate logically? And it can do that fallaciously, right? You can propagate lies and fallacies, which tend to diverge systems away from truth. Or you can make logically sound arguments, modus ponens, modus tollens, specifically modus tollens, that can converge to truth. Maybe not achieve it, but asymptotically approach it.
Get closer to it.
Hopefully.
So, because this sounds very similar to like many other modes of inferences, like like Bayesian inference and whatnot.
We actually, I think you brought that up in towards the end of the talk. I don't know, I won't claim to speak on Bayesian inference, but from what I understand, and correct me if I'm wrong, you can kind of treat Bayesian groups as kind of like group theory, and you can almost have like whenever in my talk I mentioned Venn diagrams. So if A then B, you can kind of treat the things that could cause, or A could be caused by this group, B could happen with this group. There's only so many things that allow them to overlap. You can treat that as a group and a group theory, and basically say that there's some exclusionary group within those overlapping or intersecting groups, and somewhere in there is the solution.
The truth.
Yeah.
Kind of interesting.
Yeah, I think so. And so I don't know where to go from this, but so my question to you is, do you think is this just a hypothesis you have? Is this a theory? Is this what?
Yeah, I mean, I would say right now it's a hypothesis. I don't have a pattern of evidence that I could use to suggest a theory. But to me, it at least at its best is a solid descriptor of what happens in logical arguments. Because if I make a claim, right, it's not just I only have to go test one thing, right? If it rained outside, I go look at my front porch and the porch is wet. It must have rained. It's like, yeah, well, there's other things that could have caused the porch to be wet, So I think in that sense, there's some other questions. It can't just be a one. If I'm gonna, for example, with science, if I just take one data point, I can't make conclusions off one data point.
Yeah.
So I have to take at least three. I think if we're being like even at the very minimum, right? Like at the very to triangulate something, I need at least 3 points. And so one of the I didn't talk about this in that talk particularly, but at some point it'll find its way in there. You can actually approach this geometrically, and that's actually where my interest in Euclid comes around. Because if you take this Venn diagram and you draw two circles, there are 2 points where they intersect. And those 2 points are kind of like, in a way, the 2 solutions to a second-order polynomial. If you think about, you solve, when does the ball hit the ground? At what time? And you do quadratic equation, and you get one of them's negative, one of them's positive. You just kind of throw out the negative one because time's not going to be negative. It feels a little hand-wavy, but it's basically saying if I took a Venn diagram of 2 things and I had 2 possible states, right? It's either this one at the top or this one at the bottom where those circles intersect. I'm just going to kind of eliminate one of them because that one, it's not this one, it's got to be the other one. And there's several kind of abstract things you might be able to make to analogously argue this for logic, not just a math equation. But the idea is, if you were to take those 2 circles, the Venn diagram, the overlap of the 2, and then draw a third circle, you can actually draw a triangle based on that and triangulate. I mean, you guys know geospatial tracking. They use triangulation to figure out where you are. So for me, it's this kind of idea of almost using the 2 Venn diagrams, the Venn diagram, the 2 spheres or circles, and then using a third circle as kind of your selector, your kind of bisector of saying something's within this lens that is formed by the intersection of these 2 circles. But I have to pick whether the top or the bottom dot is the right one. Well, with math, it's, at least in the kinematic example, right? Positive, negative time. Clearly, I can eliminate positive. I can eliminate negative time, select positive time. Just because we've been doing it, that's just the way you do it. But in a logical argument, how do I know if it's the top one or the bottom one? Like, how do I select or deselect one of the other options?
Yeah.
Well, you don't. You just have to draw an outline and say, well, is it in this side or is it not in this side? So with the example of rain, like maybe dew would be an example of not rain, but still wet, right? The sprinkler is going off. So there are certain things you can do to bisect that outcome and kind of isolate one of the solutions from the other one. So it has a geometrical construction as well, not just a mathematical one, which I think is pretty unique.
I have a question because you say that you use the word positive feedback and negative feedback, right? So positive feedback, I would imagine like explodes in possibilities. So when you say removing information or adding information, is that what you mean by positive and negative feedback?
Yes.
So
Yeah, absolutely.
Possibilities.
Yeah, you could think of it as possibilities too, not necessarily even just information as a brute, cold, like here's data, right? Yeah. But like if I'm looking, say, for an ACT example, there's A, B, C, D, or E. It's not A, B, D, or E, it's got to be C.
Yep.
So removing information in that way is negative feedback. I'm saying it's not this, it's not this, it's not this, it's not this, it's got to be this. Positive feedback is saying, well, it might be this, it might be that, it might be that. I don't know. It's kind of abductive versus deductive.
That makes sense. That makes sense. So it's more like narrowing down the sample and solution space.
Correct.
For whatever question.
And I'm glad you use the solution space because that can be treated in the geometrical abstract space too, not just a mathematical one.
Which is interesting.
Yeah, you're literally converging that space of possible realities.
Yes. Sorry about that. But I think the most interesting part about this is, in machine learning, you know how we can represent chain of thought and whatever and arguments in vector spaces.
Yep.
For machine learning.
They find local minimums.
They can find local minimums. I feel like it's a very...
And so my next question was like, have you thought about a problem to sort of apply this to?
No, that's where I think right now I won't take it to a thesis because right now it's a hypothesis. It's a minimally functioning model.
Yeah.
Right. I ignored during my talk the idea of saddle points. Right. There in phase space there are saddle points. I intentionally ignored them because what it's called in logical inference, as far as I'm concerned, I'm not saying this is what it's like canonically called in the literature. This is just what I like to call it, selective inference. Because it's like saying, well, there are some things that, like, if it approaches it from this way, it'll converge, but if it approaches it from this way, it's going to diverge. And so I think I haven't really
So semi-stable points.
exactly. And I don't really know what that would relate to analogously in terms of a logical argument. But I bet there's some kind of, if I were to think about it in the geometry of this Venn diagram, I bet there's a boundary at the edge of one of those circles where it's like, well, it could have rained, but it could have been dew. And depending on how I want to count rain or snow or dew as precipitation? And then, well, the ground is wet, it must have precipitated. I can kind of, I think that would be, not to get too off topic, but in the idea of like making a logical case, here's the thing, if it rained, well, okay, this is called the Mote and Bailey tactic of argument by saying, well, it didn't rain, but it precipitated, right? I'm actually kind of walking back my claim by saying, well, I'm being very specific. It rained, the ground must be wet. Well, the ground's wet. Okay, maybe it didn't rain, but it precipitated, right? Maybe the ground was dew, or maybe it was snow.
Possibilities.
Yeah, but at the same time, sometimes that's a tactic that people can use to back out of a. It's like, well, you were saying this, and this is your claim. It's like, well, that's not really what I was. I was actually saying this. It's like, no, you were saying this, and now I'm actually kind of retreating my argument so that I don't lose. Right? I still win,
I can see that.
but I'm I'm moving the goalpost. It's called Mote and Bailey.
Yeah.
Right? I'm moving back my argument to kind of still not be wrong. You know what I mean? So I think what I'm trying to avoid doing is saying, well, this is what it is. I'm just saying, well, I think this kind of analogy or geometry, however you want to think about it, the logical inferential dynamics describes very well lots of different systems, but I haven't really
You can't
prescribed.
put a finger on it.
Yeah, and I don't even know if I want to try to.
I see. I mean, I feel like it would be a very interesting paper you can write about.
Oh, I'm working on it.
Yeah, I think you should, especially like if you work with some like logic professors or something.
Yeah, well, one of the students I think he's a math major, was stuck around and talked to me about all this logical math, and I was like, I've never seen any of this stuff. I mean, I've seen some of it very briefly in like logical critical thinking maybe a decade ago when I took it. I don't remember any of it, but there's a lot of stuff that I feel like if I had a little bit more, what's the right word? If I understood the lexicon of logic a little bit more, because I'm coming at it from a physics perspective.
Yeah.
And that's why in the talk I wanted to start with all the physics analogies and say this relates to all these different fields: physics, biology, economics, sociology, anthropology. Anyway, all these different fields kind of stem out of this idea, and for me it almost feels like it kind of captures lots of different things at the same time. So I haven't really tried to prescribe, and I think to your point too, right? Are there any specific examples I want? The only example that I'm working with now is if it rained, the ground is wet. That's my kind of working model. But building up on that, I think is something I need to work on. Yeah.
Which is interesting because I feel like this kind of symbolic or inferential like reasoning, right? It's very qualitative.
Yes.
But at the same time, don't know why I keep bringing back to this, but I feel like machine learning is a quantitative like field. I use statistical mechanics and whatnot. But nowadays, since we can represent like tokens as vector spaces and meaning as vector spaces, right?
Right.
It's sort of marrying quantitative and qualitative like reasoning.
I agree.
And I feel like yours could.
It's trying to anyway.
Yes. Well, and in the animation that I gave in the talk, that was a quantitative measure. But I mean, I just tuned the knobs so it looked good. You know, like I could make some bad inference and make the graph look like you know, oh, it's never going to converge. But I think there's a clear jumping off point, because if I can treat inference as a dynamical system, well, then I just have to use the mathematics of dynamical systems, which is where I went. And I think somebody asked me in the talk, well, I think it was Dr. Lamachain said, why did you use E to the lambda T? Like why, like what about inference tells you that you can do that? And I said, well, nothing. I just assumed that because just like a dynamical system would converge or diverge exponentially with, of course, an oscillator appended to it, the same thing could be said for inference, that if I make a logical argument or an illogical argument, then I can treat it like an exponentially or an exponentially decaying or amplifying oscillator. So that was just I just like, oh yeah, you can do that, I guess.
Which is what I find also fascinating about this whole thing is, you know, Because I think sometimes you can keep yourself from maybe going down some rabbit hole because you sort of, like, for instance, one of the questions I was going to ask is like, you like to bring up some of the stuff from Ethical Skeptics sometimes, and one of the things that he has and that we went over in our scientific method episode was that there needs to be some necessity there.
Some novelty and some asymmetry.
Yeah, and so it's funny because you weren't really. It seems like you weren't thinking about whether there's necessity for this. You're just sort of playing in a way.
No, yeah. Some people even call these toy models.
Yeah.
You know, so I just thought, well, that'd be a fun thing to try. And I honestly, I was just throwing stuff at the wall because I had read Maxwell's on governors, and I thought I liken myself to an analogical thinker. Like I'm not very good at knowing the words of name. I'm not good with terminology. Yeah. So I have to relate things by analogy. Because if A then B then C then D, and if I understand A and B and then you tell me C, then I can infer D. I don't really need to know what C and D are. Yeah. I just need to understand what A and B are, which is probably like, you know, if I'm in a class and I'm talking to some biology students, I may not use the term, I don't know, electric potential, but I might use like a neuron signal or something that they, in their words, can connect to better. Yeah. Because I feel like sometimes, maybe you would agree, especially in science, lots of things are buried in terminology. And almost, I don't mean this in a negative way, but sometimes it feels like gatekeeping. I mean, it's the same thing with lawyer speak, right? There's a reason why they're loaded with all these fancy words, and I think at the onset people look at that and they think I couldn't get involved in that because it's just so deep and muddied. And I don't remember who it is. He has a quote. He says they muddy the water so they can make it seem deep. I want to say it was Friedrich Nietzsche, but I think it's somebody else. But they muddy the water so they can make it seem deep.
Yeah, that's a great quote.
But I think for me, what I'm trying to do with this is I'm trying to just stir the mud out of the water. It's a shallow little pool, but it looks horrifyingly deep. And I'm like, logic and physics, philosophy and physics are the same thing. We've just kind of, I mean, back to your point, Albert, right? Quantified philosophy with physics, which is really what geometry was all about at the beginning.
Mathematics.
Yeah, absolutely. Right.
That's
Coming up with ratios. And for me, the talk that I gave last year on everything's a ratio, right? It all comes down to the analogy, right? If A, then B, then C, then D, these are just similar triangles.
Which is interesting because if you think about it, in language, for example, when we describe something's blue, green, tall, short, and whatnot, what numbers is technically just describing the same systems, just in this case, the amount. You know, describing the system. There's 4 people, and tall, short, and what. It's just another description too. So I feel like quantitative or qualitative language, they're supposedly another description, another language.
Yeah, they almost have, they've been made to seem almost mutually exclusive, but they're kind of one and the same, just depending on what they're useful for.
Other, I guess.
Yeah.
Interesting. And so you said that these were just 2 things that you knew of, or were you reading something? And
so I had been working on this idea that because I was watching this documentary it was an online course I'm taking on Euclid's Elements. And they were arguing this, you know, take the Venn diagram, do the thing, make the triangle. How do you make an isosceles triangle? Yeah. And I was like, well, I've used this idea that everything is a ratio. Everything in science is a ratio. And because I'm an analogical thinker, the way I think about things is if you can give me the ratio, I can scale it. Right? It's all about scaling similar triangles. If A, then B, then C, then D, all you need to give me is the proportion of A and B. Give me C and I will tell you D. And so being able to kind of extrapolate, which I think is something I don't necessarily always want to do. Extrapolation can be dangerous. Interpolation is usually fine. But because not everything scales linearly, right? Some things are non-linear or exponential. But anyway, kind of in a small, localized, linearized system, thinking of analogies like triangles led me to this thought that, well, if all of the kind of logical constructs, right, the dialectics, I talked to you about pyrastics, the Aristotelian method of testing and falsifying hypotheses, that all felt geometrical. Like I could take the words out of it because I don't like words. That's my point. I don't like terminology. If I can take the words out of it and use shapes, everybody knows what shapes are.
Yeah.
Yep.
I don't need to go to, if I'm in some other country, some other language, I don't need to speak my language. I can speak in triangles. I can speak in math. I can speak in geometry, and everybody will understand. And so for me, it was kind of taking that first talk of everything is a ratio. I think of things as analogies. Logic is just a geometrical, logic could be expressed geometrically. And then seeing Maxwell's 4 modes of motion, and then knowing the 4 logical cases, which was also from that, from the class on Euclid's elements. Seeing all those things just kind of, I literally had an epiphany.
Yeah.
Because I was just sitting there, I was like, wait, like, I could treat these logical systems like a dynamical system.
Yeah.
And that, I think that just kind of opened up a lot of questions for me.
So I think it's interesting that you say that you can, maybe everybody can understand the math, right? And geometry. And so, and it's kind of weird because we sort of think in shapes and objects.
The Platonic forms.
Yeah.
In a way, yeah.
But, whenever I was reading earlier on, I just wanted to go back over, like, what is modus ponens, what is modus tollens. Yeah. And so the modus ponens is if P, then Q. And so then you're given P, therefore Q.
Sufficiently.
So, what do you mean?
Wait, so if P, then Q. If P, then Q is implied, that would be, I think, the sufficient argument.
Okay. But so, well, then how would you say this? How would you say this right here, that definition? If P, then Q, P, therefore Q.
If P, then Q, P, therefore Q.
Therefore Q.
So if P happens, Q must happen. P happened, then Q happened.
Yeah, but then affirming the consequent, which is essentially I want to say the opposite of modus.
I'm actually missing some of the terminology is fleeting from me, but in that course that I was taking, there's you have the positive argument, which is the first thing we went over. If P, then Q, P, then Q. Okay, well, the second one will be saying if P, then Q, Q, then P. Well, no, not necessarily, but sufficiently. Yeah. That's what I jumped ahead a little bit.
But see, what's weird to me is, like, on paper, it seems like to make sense. Like, if P, then Q, Q, therefore P. And it's like, that feels like the other symmetric side of modus ponens, right? But it doesn't seem to really make sense to me until you make a sentence out of it.
Well, no, I think that's where the whole P and Q really, it's just a placeholder. So, like, for me, the rain and the ground ends up being the replacement. So, I mean, maybe we could do this now. Like, let's come up with some other hypothesis. So think about it this way. You have the antecedent and the consequent, right? The antecedent is the thing that follows, the thing that if this thing were to happen, something else were to happen. And before we come up with an example, I just want to maybe use this idea of diagnostics.
Okay.
If I'm testing a circuit, say I've got a circuit, I've got like a little LED, a little motor, a little potentiometer or something, I can turn the motor speed up and up. I could test, let's just say, for example, I've set it all up, circuit's perfect, motor doesn't turn on. And I'm looking at the circuit, power supply's on, everything's good, my motor's not turning on. Well, I could think, there are abductively a couple different things that could make this true. Maybe my wires are not connected properly. Maybe my pins on my potentiometer are not properly aligned. Or I say aligned, but maybe I flip some pins around or something. Maybe the LED turns on, but the motor doesn't turn on. Well, I know the circuit's got power, but the LED, but the motor doesn't. So there are ways in diagnostics to prosecute an hypothesis. Like, okay, I'm trying to fix, my car won't start, right? Is it the battery? Is it the starter? Is it the ignition? All these different things. Well, you don't just I mean, you can try all of them, but usually what you do is you work down a line of saying, I need to eliminate this from my consideration, especially with the advent of all the electronics
Starting
in
with
cars.
the things you know first.
Usually the things you know first or can most easily check.
Yeah.
Right. So sometimes, let's say I'm in the circuit, my motor's not turning on. Well, the easiest thing to do is just take that sucker out, plug it straight into the power supply, and make sure it turns on.
Yeah.
Well, if it doesn't turn on, well, then there's my problem. I don't need to worry about trying to prosecute all the other cases of, well, what's the potentiometer doing? What's the circuit?
Yeah.
My wires are fine. And now it could be sufficiently true that the motor is broken and my wires aren't connected correctly.
Yeah.
So it kind of goes, because we were talking about how'd your week go, right? When I was running into that problem of my circuit not working, I immediately started prosecuting the necessary things first. I didn't say, well, it could be this, it could be this, it could be that. I say, if this is going to work, this must happen.
Yeah.
And if this isn't happening, well, then this isn't working.
Yeah.
So I would immediately work backwards from, if this is going to happen, this must necessarily happen. And if it isn't, well, then that thing isn't working. And so kind of working back from modus tollens, of saying if P then Q, if not P, then not Q.
Yeah.
So if I plug it in and the motor doesn't turn on and I plug that thing directly into the power supply, well, it's not my motor. I'm done. Problem solved.
Yeah.
At least in the sense that it's just the motor, right? Then I plug the motor back in, a new one. Now it still doesn't work. Well, I at least know it's not the motor because I know the motor works. Then I go to the next thing. Try the potentiometer, whatever. You see what I'm saying?
Yeah.
So there's this kind of line of argument, and they do this in law, right? They sometimes honestly walk the not the defendant. Well, sometimes the defendant, but they will walk the. I'm not a lawyer, so I'm speaking with the lexicon that I'm not even familiar with. But they usually have a line of reasoning that they know will lead to
The conclusion.
The conclusion. And it's not like, I'm just asking this to just see because I don't know. Usually they're trying to walk the
Judge and jury.
They're trying to walk them into a contradiction, because if I can walk my system into a contradiction, then you can usually find the problem with it, right? If the contradiction in this case would be, well, everything is perfect, but my motor's not turning on. Well, if the circuit's perfect, then the motor should turn on.
Yeah.
Well, the motor's not turning on, so the circuit's
perfect,
either not perfect or the motor's bad.
Yeah.
So then you swap the motor.
In a weird way, you can, because I know in critical thinking class and symbolic logic class, they use the word like valid and sound arguments, right?
Yep.
So just like what you say, it sounds good on paper because it's logically valid.
Yeah.
But sometimes
It's not
when
logically
you put
sound.
because a sound argument will only work if the premises are correct. But a logical argument is only true and valid if the outcome.
The conclusion, yes, correct. And that's where denying the consequent, affirming the consequent or denying the antecedent comes in, because if you affirm the consequent, I'm basically saying, well, see, it happened. Look, then it must have been caused by this. It's like, no, not necessarily. So in the case of sound versus valid, right? Yeah. The premises can be true, valid. But unless the premises are true and the conclusion is true, it's not sound.
Yeah.
I believe that's, if I remember that correctly.
No, it's the other way around.
Well, I think sound is the
if the premises are
valid has a lower threshold of soundness is more logically correct than validity.
But validity is if the conclusion is true. Sound is if the premises are true.
I think let's check, because if I remember right, I looked into this. Soundness requires both. I think sound for something to be logically sound, you have to have the premises be true and the conclusions be true.
So
is that right or no?
It says. Give me a
I just thought I remember the validity was the lower threshold.
Yes,
soundness is the higher threshold. Yeah. Because when we know people say, "Oh yeah, that's valid." That's valid.
Yeah.
I'm like, so it's not true though.
Well,
It's just valid.
a lot of times that's just sort of, a thing to
It's just a thing to
validate
say.
your listening, right?
Right. So yeah, what did you find?
A sound argument is one that not only is valid, but begins with the premises that are already true.
Okay, so they're already true, not necessarily if they're true.
Yeah, so
I see.
So
right.
the premises have to be true first before the conclusion. Because even if you have the conclusion and the whole argument lined up, if the premises are not true, it's still.
But soundness doesn't require the outcome to be true. It just requires that the premises are already true.
Yes. So
and then valid is saying if they're true, then the conclusion follows.
Yes.
Yeah.
So I have a philosophical question. So do you think that? I mean, like, what your goal? Like, what would be your, I don't know, goal for truth, right? Is because I know that there's, you know, a lot of things that just feel not within our grasp,
Yeah.
right? And so, do you feel like, and I'm thinking like thousands of years from now, right? There's ever going to be a day where we could just know it all, and is there like, and is the scientific method good enough to do that?
Okay, I like the second question, or the second part of that. But I want to almost piggyback on what you were saying earlier, asking me earlier about, you know, was there any, like what made me want to do this if it wasn't necessary, right? Like why there wasn't any reason. I just thought, oh, that'd be cool, I guess.
Yeah.
But ethical skeptic has this thing called the ACAM problem, and I'll probably mess up the acronym, but it's basically you have to have something that's asymmetrical, novel, and there's one or two other things, and I'm blanking on what they are. But I certainly saw some asymmetry in the logical inference, right? With if I have a fallacious argument, I could have something be 90% true and stack on 10% fallacy. And that 10% fallacy stacking on top of a 90-10 ratio, over time, that fallacy will dominate the truth. So even if there's this great quote, and I don't know who said it, but a lie will travel around the world before the truth has time to put on its shoes. So think about that, right?
Yeah.
A lie can propagate all the way around the world before the truth is just getting its shoes on.
Well, that's what's weird. It's like sometimes the lie it's more interesting.
It's easier, right?
It's more fun.
The logical fallacies of affirming the consequent and denying the antecedent are easier. It's not hard to do them, so it invites. It's just easier. I would just say it's logically lazy. I'm probably being, elitist. But the idea is that it is always more sufficient to argue necessity. Sufficiency is sufficient, but it's difficult to argue necessity, right? If I were to say, well, if the ground is wet, what must have caused this? There are many things that could have done that.
Yeah.
So working backwards from that and saying, well, okay, it didn't rain, or maybe it was the dew, or sometimes finding necessary things is harder than finding sufficient things. And that's where,
makes sense.
Yeah, I think that's where you have this asymmetry, right? Where logical, valid inference is harder to do than invalid, fallacious logic. One, because it's more tempting to be fallacious, it's easier. But the other one is because answers are hard to come by, right? Measurements are hard. It's easier just to, it could be this, it could be that, who knows? Well, I went and looked, and this is what I found. It's not that. That takes effort. It doesn't take a whole lot of effort. What do they say? It's easier to destroy than to build. So whenever you're trying to build a case,
Entropy, right?
Yeah, they're all related.
Yeah, because it's
Yeah.
easier to get it's easier to diverge the possibilities than to converge onto one
to order.
To order, yeah.
Yep. Yep. And I think that's the point, is that I think maybe to the question you had earlier, like why do this? Like, what's the necessity? It's not that there's some truth that I think will be revealed, but I think it's, to follow up on the second part of your question, right? Is the scientific method sufficient? And I think as the ethical skeptic, as the reading that I've done from his work, right?
It's not enough.
I don't think it's enough, because it allows for fallacies to propagate. So a better model would not, I don't want to say eliminate, because you have to be able to make mistakes, but the system should be able to identify those errors and allow for them, right? If I think I mentioned in my talk, when they were measuring, and I'm going to mess this up, but they're measuring like the mass of the muon or something, or the electron volt, I don't know. But for 20, 30 years, the measurements, they had these error bars, and then over time they get smaller, and then in 1992 or somewhere, there was this giant outlier. And if you would have had your confirmation bias, you would have said, well, that's an outlier, it can't be true, right? That's too far outside of our tolerance. But that's actually closer to the real measurement. And so being able to, I think I used the word epistemological humility, right? Epistemology, how do we know stuff? But being humble and having humility by saying, I know that I won't know some things. So that if I make a measurement that's outside of all these other 20 years, 30 years worth of measurements, and I'm like, well, that's way out there. Yeah, but being humble enough and having the humility to say that actually could be what's correct, though. That's hard, right? That's way harder than stopping some fallacy on it and say, well, that could have been caused by this and this and that, and trying to explain it away. Yeah. Rather than actually considering it that might actually be the thing that's more true. That's a scary thing, I think, for even in science, right? That the scientific method should invite criticism. I mean, I'm sure it does. There's peer review for a reason.
Yes. Yeah.
But sometimes you almost get into this kind of self-propagating spiral of, well, we've been doing it this way for 30 years. And then there's the Kuhn-Planck paradigm shift, right? That science advances one death at a time. So it isn't until sometimes hundreds of years later that the theories, the knowledge, the models that we've been using are outdated and discarded. And as ethical skeptics says, they almost rot from the inside out. That they don't appear like an apple rotting from the outside in. You see it, right? It rots from the core, and you don't realize it until it's too late, and then you have to just throw the whole thing in the trash.
I mean, there's a quote by Carl Sagan. I think is very perfect for this situation. He says, "Science is not perfect. It can be misused. It's only a tool, but it is by far the best tool we have, self-correcting, ongoing, and applicable to everything." But do you think, because Sabine Hossenfelder,
Sabina,
her criticism is that most of science today, regardless if it's biomedical field or theoretical physics route or particle physics route or whatever, a lot of them are becoming pseudoscience in the sense that they're creating models or researching in only directions that will get them
self-propagating.
Grants. That will get them either grants.
I agree.
Or just creating, for example, mathematical creation myths. Because, for example, there's so many different theories of everything. At that point, you have different.
So, ethical skeptic, I'll probably quote him 1,000 times here.
Totally fine.
But he talks about this thing that, if I can remember the name of the principle, but it's basically something that explains everything and nothing at the same time.
Waving away, God.
Yeah, it could be everything, it could be nothing, it doesn't really matter. And it's like, well, if it explains everything and nothing at the same time, it's worthless, right? A real, true, critical path hypothesis is either true or false. It can't be both. And if I'm like, well, it could be true, it could be both, it could be false, so it doesn't really matter. This isn't science. It's pseudoscience. And I agree with Sabina that there's a lot of that. Probably more than I think people want to admit. And don't get me wrong, I'm not inundated in the research field. I'm just a guy at my house coming up with ideas.
But I think you should get paid for that, though, right? So like, there's a great podcast I was just listening to the other day. Kurt Jaimungal, he's I believe he's a theoretical physicist, and he has a great podcast where he interviews a bunch of these other theoretical physicists, and I think his podcast is called the TOE podcast, Theory of Everything podcast, where he likes to dive into all these ideas of the theories of everything.
He's probably had Eric Weinstein on a couple times.
Yeah. And so he had David Deutsch on the other day, and they were talking about how for one, David Deutsch was like, I feel like I wouldn't have survived in today's how do I say, like, ways to get a grant. He's like, I feel like I wouldn't be able to get a grant today because a lot of my stuff is sort of, there's not a
fringe.
Yeah, and there's not a box I can check to say this is what my research is going to be.
Research, or I'm doing right.
Yeah, and so like they were talking about Einstein. Would Einstein even be able to do the research that he was doing?
Like Einstein got the Nobel Prize for the photoelectric effect, not even special general relativity.
Yeah.
So kind of to that point, right? I think the photoelectric effect has some clearly demonstrable evidence that he could, go and give an exposition of. But to demonstrate the theory of special relativity, the closest thing you can do, and I think this is, I talked about this the other day in class, the Doppler effect. That's a relativistic phenomenon. But that's not what he got the Nobel Prize for. And so would Einstein get funding for the general theory of relativity? Probably not.
Yeah, and
Right, that's the things where you're going, right? Yeah.
And,
I don't think so.
And it's weird because there's these weird parallels between the music industry and
Hollywood
and research.
It's like the Hollywood of physics.
Or science, because so the music industry they think that they have like a formula to make an artist,
Right.
but
Well,
you should just let the artist be an artist.
Sure.
And don't expect them to fit into a box, right? Just give them the money and go let the artist be the artist.
Right.
And I feel like that what needs to happen with more research and research grants is like just because this is an art in a way.
I agree.
I mean, I think what you did is very creative and definitely can be seen as an art. And we need more of that, right? And so
I agree.
and
Yeah, it's weird that I would probably be an outsider saying this, right? Because I don't have any peer-reviewed publications.
Yeah.
But I don't think that's really what I'm after. Like,
Yeah.
I think peer review is important, absolutely, in science, right? If your theory cannot be tested and disproven, especially if your theory can be disproven, there's no point talking about it. But if somebody else can't go test my theory, then what's the point?
Yeah.
But at the same time, I don't think I'm out here seeking validation, right? I'm just proposing an idea, and if somebody wants to say your idea sucks, I'm okay with that.
But at the same time, though, right? If someone else wasn't if Newton wasn't talking about his ideas to other people, no one would have ever found out because it wasn't Newton that published his stuff. It was somebody else.
Yeah.
And so I get where you're coming from, right? But at the same time, we need to also have this sort of feeling that
I think we need a renaissance.
No matter what our idea is, it should be out there.
Well, and I think that's where I come from too. Is the chance of me publishing this inferential dynamics in Nature is slim to none, and that's not because I don't think it's novel or asymmetrical, but
that's
it's
the
because
one that everybody's trying to go for.
It's
Right?
because there seems to be, and I think Sabine is the one who I gleaned this from, Sabina, that there's a lot of, I'll just use the probably not so nice word, like almost inbreeding of just self reinforcing dogma.
Yeah.
And it's like, well, if you're going to go outside the status quo, good luck getting published, right?
Yeah.
Good luck getting funding if you're not doing something that's kind of within this box, this bounded, the allowable topics, if you will. And I think that's where even somebody like the ethical skeptic sometimes gets some flack because people are like, well, he's anonymous, or who peer reviewed his work. And I think maybe just to be a little bit of an obstinate dissident, where are your sources? Show me your sources. It's like, well, sometimes I had this given to me in a dream.
Yeah.
This is something I came up with. I don't have sources, like the Charles Pierce, one of the guys I mentioned in my paper, 1878, 10 years after Maxwell. Never heard of Charles Pierce. But kind of having an idea and sharing some of that with his work, I come to find out about him.
Yeah.
But it isn't to say, well, my idea came from Charles Pierce.
Yeah.
No, it just, I use him as a reference because somebody else shared this idea with me.
And so he's the guy who came up with deduction, induction, and abduction?
No, Charles Pierce is the one who said that truth is the stable outcome of inquiry.
Okay.
And that was 1878, which is really at the advent of dynamical systems. And I don't, from what I understand, when I gleaned very briefly in the time that I spent looking at Charles Pierce's work, he did it very qualitatively, and Maxwell was very quantitative. And so for me, it was kind of literally bridging the gap between this kind of abstract geometry of like, oh, is it like kind of like woo-woo, or just like drawing shapes on the wall, taking it to let's make some logical statements with words, which would be kind of the more Greek approach, right? Obviously geometry as well, but kind of the Aristotelian dialectic of pyrastics, right? Making a claim, Socratic method 2, asking questions, and then kind of pairing that with Maxwell's. It actually really comes from Galileo too, because Galileo, along with Archimedes was the first experimentalist, but Galileo kind of correcting Aristotle in the sense that constant force doesn't imply constant motion. It's just that a force causes a change in motion. And so where does change in logic come from, right? It comes from a force. If I've been thinking the same thought, nobody's ever going to, just law of inertia, I'm just going to keep thinking it until somebody comes in and says, hey, have you ever thought about this before?
Yeah.
And I'm like, oh my God, that's a great idea. But it isn't all the time that you just have that force that just comes out of nowhere. Sometimes it happens within, right? There's some kind of sudden realization that you have, and there's a cognitive bias that you think, well, that's too out there. No, that sounds super fringe. And if anything, I think sometimes the things that are out on the fringes are the most interesting. So anyway, that's, I think, where I spend a lot of my time is thinking about some weird stuff that most people probably wouldn't even give the time of day for.
It's like, I understand how like science verifying theories need a lot of crude, vigorous steps, because of course if science is not vigorous, there will be a lot more pseudoscience. But I feel like that should not stop people from using their creativity to come up with new ideas.
Well,
you cannot claim those new ideas like hypotheses as truth. The same way we can't call string theory a real theory yet, because it's mostly still a hypothesis.
Well, and gravity is still a theory.
Yeah.
So I think that's kind of, for me, there's this I don't want to say just lingering doubt, but if somebody's like, well, what do you believe in science? Like, well, science is a culture of doubt. Religion is a culture of faith. That was Feynman.
That brings me back to Carl Sagan. He says science is a way of thinking much more than it is a body of knowledge.
Yes. Well, and that's something I mentioned too in the talk. It's not about stacking a bunch of facts on top of each other. If anything, what a good model would do is say, well, all of these, let's just say I have 10 facts in front of me. All those 10 facts, surely, if they are all true, have some commonality. And I can take those 10 facts and turn them into 8 facts, and then turn those 8 facts into 4, and those 4 into 2. And if there is such an ideal world that I could turn those 2 into 1, then I have the single truth. You know, that out from that one truth stems all these other 8.
The grand unified theory.
Right. And I think my take is that I'm not saying that there exists a single truth at the bottom of all of them, but we have all these other ideas, and whether it's mechanics, electromagnetics, socioeconomics, all these different fields, there's something about all of them that's in common, and it's this idea that truth converges with good logical arguments, and that's true in law, in case law. That's true in finance. They literally do this. I've talked maybe sometimes about. I don't know if I talked about it in the last podcast, but actuarial forensics. I actually kind of do my own actuarial forensics by taking all of my income, right? And I look at my income, outcome, net flux, if you will, right? Income, outcome, take the difference of them. If there's extra money, if I have a positive or negative, I also track the second order rate of change. So I think about the force on my system. Well, if I have a constant flux, right, I only make so much money a month and it's always the same amount roughly. It's like the water faucet's turned on maximum. Well, if there's extra water coming in or extra water leaving, somehow there would have to have been a force, right? Back to Galileo's point about forces don't cause motion to continue, they cause motion to change. So if there's a change in my motion, a change in the equilibrium of my system, whether it's a financial system or a logical system,
something must be going on.
Something must be forcing it to happen. And that force is the truth. Whether that's
it's happening.
Exactly. That's exactly it. So what I'm all about is I'm trying to detect these forces, right? So when I'm let's just, for an example, I love debating people. So like if I'm in a debate with somebody and they make a claim and I say, well, that's a sufficient claim, but it isn't necessary, right? What I'm doing is I'm saying, well, that force isn't really there. It's a fictitious force, maybe in a way, right? So what I'm trying to look at is, in order for a logical claim to be fully sound and valid and then sound, there must be a constant equilibrium in the system. If there's an extra force, maybe positive or negative, it will tend to influence that logical argument. And so for me, it should be a good model will survive on its own, right? Any scrutiny, anything that I try to throw at it, it will bounce back.
Okay, so
they do this in economics too, by the way, with economic shock testing. If you want to look up some really fringe stuff, there's this thing called I'm gonna probably get you guys in trouble.
Yeah, it's fine.
It's this thing called silent weapons for silent wars.
Silent weapons.
There's this whole idea about how
or for quiet wars.
Silent weapons for quiet wars. Why computers were invented to basically model the stock market.
Okay.
So that they could control the stock market. And not just the stock market, but the whole industry.
Yeah.
And so there's this thing called economic shock testing where they'll change the price of milk and see how the system responds. They do this in signals and systems, and I'll never forget this. I think I mentioned this maybe even last time I was on. Dr. Benjaber said, and I'll never forget it, if you want to know how the system responds, poke it. The system will either respond positively, negatively, or not at all.
Yeah.
And that's exactly the three modes of stability, right? It's either positive feedback, negative feedback, or no feedback. And they do this with economics. They do it with every field of quantitative science.
Yeah.
And so for me, it's a systems theory approach, not this is a physics thing or a philosophy thing. It's a systems thing. And logic is a system, just like science.
I love it.
That's very poetic.
So, okay, so let's say, for instance, like relativity, right? You know, it makes a whole bunch of great predictions. It's a very good model, right? But then Karl Popper has this idea that one falsification
it's out the window.
Does that mean like, okay, so if we find one falsification of relativity, then we just have to completely erase that model from our minds? Like,
okay, I see what you're saying, and my rhetorical response would be, that's a hyperbolic way to say it.
Okay.
But saying we have to completely get rid of it, right?
Yeah.
So there's this whole idea of throwing the baby out with the bathwater.
Well, that's what it feels like to me.
I know. But what I mean is, so let's say that you're giving your kid a bath, right? Baby in the bathwater. You drain the bathtub, but you don't drain the baby through the bathtub. You don't want to throw the baby out with the bathwater. Throw the bathwater out, keep the baby, right? Chew the meat and spit out the bones, right? So there's this idea of like, well, if I think special relativity is fine, by the way. I think general relativity is the one that's probably going to be called into question. I'm sorry, even Sabine has talked about something. So, but the idea is that if there's some type of falsification event, like black swan, white dove, or white crow, you don't have to just throw the entire baby out, right? But there's every lie is built on some foundation of truth, otherwise it wouldn't stick. And so there might be something that's worth keeping in general relativity. I think what's worth keeping is special relativity. But there's probably somewhere, I don't know where, but that's kind of where my thesis was all about. It was like, what maybe in the 1800s, late 1800s, when they're talking about wave theory and Heaviside predicting gravitational waves before Einstein did, this idea of, well, maybe somewhere we just took the wrong turn. And back to the idea of this logical fallacy and divergence convergence. Well, if you follow a fallacious argument, it will diverge. And so maybe at some point science, at least in the kind of modern physics of the 1900s, kept following a fallaciously divergent path, thinking by confirmation bias, it's good. It's a dog chasing its tail. There's my tail. I'm getting precise data. Yeah, but you're not accurate, right? So I could be precise as much as I want to. Go outside. There it is. The ground's wet on my porch. Oh, look over there. The ground's wet also on my porch on the sidewalk. Yeah, but that was a sprinkler, right? So you're not wrong. You're just half wrong. So incomplete. That's the same thing with quantum, right? I think we've had that discussion. So I think in the sense of relativity, right? I think special relativity, as far as I understand, is totally sound.
Well, and that's
but general relativity is where I think it was taken and ran, and it was like you got to slow down a little bit, because I think it just went too far.
That's what Einstein felt about quantum mechanics. He felt it was incomplete.
And in a way, and I mean, I'm not Einstein, and I'm not. Maybe I'm projecting, but maybe Einstein was projecting because maybe he in himself knew or considered or even thought possibly that his general relativity was also incomplete. And so maybe when there's this other alternative that comes around, it's like, quantum mechanics might actually be more descriptive of the universe. And he's like,
Is
Well,
it?
no, yeah, kind of. And
Well, I mean, it just seems like every model is going to be incomplete, no matter what.
that's my model's incomplete.
That's true.
Absolutely.
I think I think that's the main part though, is that no matter how good your model is, it will always be incomplete because there's always something we don't know about the system till later on.
Yeah.
And that's a big part. It's till later on. We could have a model that works for 100 years. I mean, and I mentioned this in my talk.
Until
Ptolemaic model of the universe, the epicycles,
It worked.
it was beautifully explanatory,
Yeah.
but it was so damn convoluted that it's like, well, I mean, you almost have to be like a genius mathematician. I mean, the Fourier transform is kind of that idea of all these little circles and circles and circles, and it's very precise, but it's entirely inaccurate. Because that's not how, if you want to use Einstein's terminology, it's not how space-time curves. It doesn't curve as all these weird circles. But it's a sufficient model, not a necessary model. I think that's kind of where, even in a systems perspective, right? It is a sufficient model, but it isn't necessary. And that's where I keep trying to go back to is, it must be necessary for it to be worth keeping. The baby is necessary.
Yeah.
The bathwater is sufficient.
I see.
Yeah.
And so,
Because I can get more bathwater. I can't get another baby.
well,
Yeah, I gotta wait.
that's
Maybe it takes a little time, right? Yeah.
That's hilarious. So it seems like your first approach, it's like was really, you were just having fun, you're interested, but like as a secondary or maybe even a ternary, I don't know, thought is, have you been thinking about like, okay, maybe we can use this to get closer to truth, or?
Oh, absolutely. I think it's already the way, and I probably didn't do the good enough job in my talk of making this clear. It's supposed to be a tool that can be used. Like as soon as that talk was over, this is something you could take with you and use this arguing for necessity anywhere, whether that's in just a little argument you have about where we want to go eat lunch, whether that's what are you going to do with the finances, what are we going to do with, how am I going to diagnose this circuit?
So how would I use that, like today? How would I?
For me, like what's necessary for tomorrow? What do I have to have done tomorrow?
Okay.
What sufficiently need to be done by tomorrow?
Okay.
Maybe thinking about this now, there's this thing called the Eisenhower method. He has 4 modes of operation.
Okay.
And I'm laughing because I just thought of it. I've used this thing, the Eisenhower method, for years. And you said, well, how can I apply this today? Well, I thought this thing called the Eisenhower method. Back before, you had email and whatever, he had these 4 stacks on his desk.
That's right. Yeah.
I told you about this. He had 4 stacks on his desk, and the first stack was necessary and urgent. The second stack was urgent but not necessary. Then it was it was both necessary and urgent, then urgent but not necessary, then necessary but not urgent, and then neither. And so you're getting, again, one of these little 2x2 matrices. But
like a little quadrant.
Yes, and you're almost arguing sufficiency and necessity by saying this has to be done tomorrow. Like when I was diagnosing my circuit, right? In order for this to be done by 10 a.m. tomorrow, what necessarily must happen? I want the bells and whistles, I want the cool LEDs, I want all these things, but those are only sufficient. They don't need to be there. So anything that you do, whether it's in studying, whether that's planning your food, groceries, spending money at the grocery store, bills, any system that my thing is, everything is a system, everything is a signal. So whatever signals you interact with the most. Some people track all their calories and carbs and protein. I can't keep up with all that, but they're doing it for a necessity, right? I need to consume 200 grams of protein a day. So kind of arguing from a necessary standpoint of like what must be done, because there's ethical skeptic once again has this idea that sometimes in a state of panic, you just do things without thinking. You just kind of sufficiently act, which isn't bad on its face, but could be. And there's a Latin phrase called quod et fieri, which means something must be done. And so, in a panic, the example he often uses is there's a fire in a crowded theater, right? In this fire in a crowded theater, sometimes more people can die from being trampled on than die from the fire. So it's the reaction that actually introduces more risk than the actual action that needs to be taken. And so what's necessary, right? Well, it's sufficient for everybody to run and scream and panic and trample on over each other. but it's necessary that everybody has to leave, get out of the room. You could walk out a single file line. You think you're going to get people that are panicking to do that? But I think the idea is that in any type of problem that you're trying to address, whatever that problem is, whatever that signal is that you're trying to measure, ask yourself, is this necessary? Or is it just merely sufficient?
Yeah. I love it because it's like, I would probably only use that during the semester.
You'd be surprised. I use it in everything that I do.
Okay, nice.
I mean,
that's probably why you're so productive.
yeah, I like to think I was.
So, do you have like a favorite? I don't know any other way to say this other than, do you have like a favorite elusive truth? Like, for instance, like the
I do.
If when is the beginning of time, right? Or it sounds like you already have an answer. So
yeah, well, it might have something to do with the beginning of time.
Okay.
The beginning of human time. How do I say it the right way? How long has mankind actually been on this planet?
Yeah.
And are we actually the most intelligent civilization? I don't think so.
Now that would be interesting.
Yeah. So, and this is an unfalsifiable claim, right? That I'm going to make, but some people say that every 6,000 years there's a global cataclysm. I want to say it was 12,000 years ago. There was a genetic bottleneck for males that 19 out of 20 males died, and only one remained. So something happened catastrophically, cataclysmically, around 12,000 years ago. And there's this whole
Is that
thing
the
about
Younger Dryas impact theory?
Yeah. There's some people talk about it as maybe it's an impact, maybe there's an asteroid. Some people talk about it as there was some kind of climate disaster, right?
Yeah.
There's some magnetic pole shifting, the ice age. Who knows? But to me, there seems to be some evidence that suggests that mankind is not as young as we think we are. That I think even just a week ago, they found some skull that dated to like 1 million years ago. And they're like, well, we only thought civilization would have been around for 100,000 years. Right? This whole idea of like hunter-gatherers and from the Stone Age and blah, blah, blah. Well, this idea of human tools, right? According to this archaeological find, mankind's been around for hundreds of thousands of years, far, far before the previous timelines. And so it's like, well, were we just running around and like, playing with fire? No, these people were building structures and symbols. And the biggest example of this, anybody wants to go look this up, is Göbekli Tepe. And
so great.
It kind of breaks.
Spell that?
That's a great rabbit hole.
Gobleki.
Wait,
Gobleki, Göbekli, and then Tepi. Maybe Tepe. I think it's Tep.
Oh, I found that.
Is it Tepe? Yeah. Göbekli Tepe.
Tepe.
Yeah. There was this whole thing about the not World Health Organization, the World UNESCO. I can't remember what it is.
Yeah.
One of those world
UNESCO
organizations.
UNESCO. Yeah, they were kind of banning people from going and investigating. And Ethical Skeptic makes a point that this is evidence of human history. This is a right that we all have as human beings to know about why this structure was built. And they're blocking people from researching it.
Yeah, that's
At
weird.
least as of recently. I think they've now allowed some people to start. There's a guy named Jimmy Corsetti who's been doing some research on
As
this.
of 2021, only 10% of the site has been excavated.
And the point is that we've had all this time. Why have we? It's almost like they're dragging their feet because. Well, what if we find something out that says, well, the whole paradigm of human history is just completely shattered?
Yeah.
And so, to your point, I think the question, right, is there some truth that I think is probably the most evasive? It's how long has humankind actually been advanced? And I think there's some evidence out there that
The world's
they were
oldest
far more
megalith.
advanced.
So how do we go about finding that out?
We have to prosecute the case. What's necessary? So when they built these sites, what were they doing? Right? What did they want to find? What were they trying? Maybe not even trying to find themselves, as if like they were searching for something. But what were they building these things for? What was the purpose? Right? Any engineering project has a purpose. You don't just make something for no reason.
Function. Always.
Yeah, form and function. And what's kind of I think beautiful about Göbekli Tepe or a lot of these places is that they have all this art on them. And the art, some people say, is just stylistic. It's just there for show, right? It's the aesthetics. It looks nice. Religious, absolutely, right? But what if it's a story? What if it's an instruction set? What if it's actually them telling us what it's for?
Or like leaving something behind, right?
Well, and why would there be all these monuments that seem to point towards it's called the Euler axis. It's a secondary gravity. So without going into the whole thing, there's this theory called the ecto theory, exothermic core demantle, the core mantle decoupling Zanny-Bacov oscillation theory.
Oh, okay.
And I've showed you about this, right?
Yeah.
So the idea is that there's this Zanny-Bacov effect. You've seen them in the International Space Station. That the Earth does this every 6,000 years. Well, if it does that every 6,000 years and it flips, there's a small period of time where it stays in a semi-stable orbit, right? So it's stable for 5,600 years, flips for nobody knows how long, according to this theory. Nobody's speculating. I think that's a good thing. But then saying it flips back. And all of these, not say all of them, a significant majority of these ancient sites point towards an old North Pole. That, to me, is incredibly compelling.
An old
So the
North
scientific.
104 degrees of separation from our current North Pole. And the crazier thing about that is that the pyramids of Giza, the Khufu pyramid, I think specifically, the inclination of the quote-unquote air shafts in this pyramid are inclined at 104 degrees.
Whoa.
And there's two sets. So the fact that these Egyptians, or if it was even the Egyptians, whoever they were, not... I don't think it was the dynasty of Khufu. I think it could have been the Egyptians, local Egyptians, but not under Khufu's reign. They probably rebranded it and retitled it. But the idea is that if they could have built this, as far as I know, nobody still knows how they built the pyramids.
They tried to say
if they could build these things at 104 degrees in the pyramid, that takes an immense level of precision we can't even fathom. So how do they know it's 104 degrees, and why did they build two of them? Because maybe there were two states that the Earth oscillates between, and that they were using these as not a tomb, but a watchtower to see when the Earth would actually change.
That would be wild.
And that's a woo-woo fringe theory.
Speculation.
But I think there's some substantial deductive evidence that shows that the pyramids were underwater, not just under like a little bit of water, but under significant turbulent water for a sustained amount of time. And that they knew this was coming and they built this for a reason.
Perhaps Noah's Ark.
Well, no, I mean, you're not far off. It actually, as Ethical Skeptic talks about, it's more of like Utnapishtim, right? The legend of Gilgamesh. That Utnapishtim, all these ancient cultures all around the world, they all have stories of a global flood. And running to the hills, right? There's lots of
wild,
and even not necessarily religious or spiritual. There's lots of cultural iconography of floods and mountains, of running to the hills, right, to evade floods. It's in music, it's in art, it's in literature, it's everywhere, and it's ingrained in our psyche, in my opinion, that there's something about global cataclysm that if, according to this kind of theory of the genetic bottleneck, we are the survivors of the previous cataclysm. And to me, that's great. It's almost it's kind of like the most beautiful story I've ever heard. There's a movie, or there's a show called The 100. You might have heard of it. Well, that's the idea. Is that did you watch the movie or the show?
The book.
Oh yeah, they did have a book. Well, the idea in this show is that, long story short, they built this AI. The AI was instructed to save humanity. There's this thing called perverse instantiation, where if I tell, hey, make me smile, the AI could tell me a joke. It could like grab my cheeks and pull them apart. There's lots of different ways it could go about making me smile.
Drugs to you,
make you crazy. So in this show, the AI was supposed to save humanity, so it nukes the whole planet. Because that's the way it interprets saving. Because there's like all these scientists, like the kind of upper echelon, the elites that are in this satellite, the space station, I should say, not just a satellite, the space station above Earth. And they're according to the AI, the only ones that needed to survive for humanity to continue. And so it just nukes the rest of the planet. Well, of course, some people survive. There's the whole thing of the Grounders. Do you watch the show? I might spoil it. It's a great show. But the idea is that there's kind of this cutoff point where after, let's just say 5,000-6,000 years ago, when 95% of the male human population declined, that we are the product of a series of cataclysm survivors.
Interesting.
I think that's a fascinating story of humankind.
Yes. I mean,
This type of thing is what makes me feel like we're in a joke.
Yeah, we need to get a sign or something over here that says woo-woo talk.
no, I love it. I mean, I think it just speaks to your open-mindedness, which is one thing that definitely makes me gravitate towards you and wanting to, whenever I have like a new question or a new thing that I've come across, I always like come to you and like, have you heard of this? Or like, what do you think of this? Or,
I love that.
Because just because you're open-minded and you're willing to just listen to new ideas and
Always.
Yeah.
Well, in something too, right? A lot of times when people criticize ideas, it can come across as them being criticized themselves. And I had to learn, if I even can say I've learned this completely, you have to separate yourself from your ideas. And so when somebody criticizes your idea, it's not them criticizing you. They're just criticizing your idea. And so being able to detach yourself from ideas is, I think, maybe the improvement that needs to be made to the scientific method, even though that's more of a philosophical thing. If science can only advance one death at a time, well, why is it stop? What is it about death that enables science to grow? Well, it's because you don't have the dogma or the paradigm or the social guilt or whatever you want to think about. That if as a historical story, Newton, as like a 17, 18, 19-year-old kid, was arguing with Robert Hooke, who was like, 40, 50 years old. Robert Hooke invented wave theory. He was the first one to really study waves. Robert Hooke, Hooke's law, springs.
To the springs, yeah.
Well, he had the idea that light was a wave. And Newton's like, no, dude, I got this thing called a prism, and look, that's a ray, that's a beam, that's a particle. And it is because of Newton that we've come to know light as a particle. Even though in the late 1600s, Robert Hooke said, no, it's a wave.
Which is crazy.
And then now we have 300, yeah, exactly. And 300 years later, now we're back to the argument.
Yeah.
And it's like we've literally come full circle. And it isn't just because, well, Robert Hooke was old and Newton was young, but it takes somebody dying or somebody to really stand up to the current status quo, the paradigm, and question it for any type of change to happen.
Yeah, I think that
force.
sort of relentless search for the truth.
Yes.
Right? Like, we at one time didn't know that there were atoms.
Right.
Right? And
Democritus.
I think Dr. Teo was sort of asking a question related to this. It was like, there's points in history where you have a lot of people saying, oh, no, there's no way that could be true. There's no way that everything's made up of these little tiny atoms or whatever. Like, right. I break this apart into smaller pieces. You see that there's matter there. There's, this thing that you can feel and touch. And it's not until, there's these people that come along that are just like, no, I'm not going to listen to anybody. Well, maybe I will.
The irreverence that Feynman mentioned.
I'll listen, but also at the same time, I'm not going to attach myself to those ideas, and I'm going to just do what I can to come up with the experiments that we can for the day to try to find the bleeding truth.
Yeah.
And that's what I love about just science and scientists is just my most favorite ones are the ones who are just relentless in that truth. And
that's why I mentioned Feynman's quote earlier, because there was always something about Feynman that just resonated with me because dissenting opinion is so important, right? If we all disagree, then what's the point? And Johannes Kepler, when he was talking about his Keplerian, laws of planetary motion, he was actually rejecting the circular theory at the time, right? That everything just moves in these perfect circles. The angels dance the planets around in these circles, and they create a song, and that song is called the universe, the one song, right? But Kepler said, no, the universe is still a song, and it's harmonious, but it has discord in it. It has dissonance, right? We talk about dissonance and
That's
consonance.
There's some Beethoven in it.
There's no, and he did. He actually mentioned music, because one thing that even gives me goosebumps thinking about it is because I'm a metalhead. I love music. I love metal music. There's discord in metal. If you're a big metalhead, you know what I mean when I say discord. You get goosebumps sometimes listening to music. Well, Kepler said in his, I can't remember the Mundi Harmonica or something like that. The on the harmonies of the planets, something like that.
Yes.
He said that the dissonance is like cooking with salt and vinegar. Right? You don't have a bunch of it, but you just sprinkle a little bit in there, and it gives it the kick, right?
Yes.
And so if 90% of everybody agrees, but then you have 9 people that agree, and then one person that says, "No, I don't," that is more important than the other 9. Right, and I think Aristotle said this. You guys can pull up my website and you can find all the quotes. But somebody said, I think Kepler even said this: I would rather listen to one critical individual than the mindless agreement of the masses.
Like 15, like let's say 15 million says something wrong, it's still wrong. You know what I'm saying? Like,
Yeah.
Well, shoot, even like matter and molecules, right? The reason they form is because of sort of what would you call it? Not deformations, but like, oh crap, yeah, basically like it starts with a D. Anyways,
I'm not sure.
Man, so basically like atoms have to have something to sort of like grasp onto.
Oh,
right?
yeah, like they have certain like stable bands and orbital bands, and things have to be in certain configurations. Is that what you mean?
No, it's like it's more or less like a deformation, and if things don't have a deformation, you're not able to come together.
Like if they were all perfect circles or spheres, then they couldn't actually mate.
Yeah.
But they need like something to kind of like latch onto, like some irregularity.
Yes, exactly.
Yeah, and I think even before we started the podcast, right, that asymmetry is what's most compelling. If it's completely symmetrical, it almost feels weird. But there's something about asymmetry that I think is reflective of nature. And that's...
Yeah, I found the Kepler's quote. I much prefer the sharpest criticism of a single intelligent man than to the thoughtless approval of the masses.
Yes.
That's crazy. I love that quote.
Based.
Facts.
Yeah.
Man, I wish I could find this word, because it speaks exactly to what your deformations, dislocations. I'll figure it out later. Screw it. Let it go.
I'm not too familiar with all the atomic theory stuff.
Yeah, man. It's at the tip of my tongue, and I just kind of, I hate that. But anyways.
Yeah.
Anyway, so one of my questions, I guess, that I've come across lately that interests me is, and I don't know, you're probably not gonna have an answer for this, but I don't know, maybe you've had a thought about it, right? Is why weren't we born with more information?
You mean like in our brains already?
Yeah. Like for instance, why don't we come with like
I think we do.
Like why don't we come with knowing like about quantum mechanics and we have to discover these things, right?
I mean, what an evolutionary biologist would say is we evolved to survive, not evolved to know. It's just that
that's a good point.
Knowing along the way is a part of discovery and survival,
right?
To make things easier and better.
Yeah. So I want to dance around with one thing because you mentioned Kepler's quote. I'm so glad you found it. Have you ever heard of the Asch conformity experiment? This is psychology.
I don't know.
So there's this thing called the Asch, A-S-C-H. I think there might be an E on the end, but I think it's just A-S-C-H, Asch conformity experiment. But the idea is there's kind of two different modes or versions of this. I think the historically canonical one is you have 5 people in a room. Are you seeing it? Where they have 5 people in a room and they hold up a piece of paper with 3 lines on it, and they say which line is the longest. And they show it to everybody in the room. The first 3 people are in on the test. They know that this is a test.
Yes.
The 4th or 5th person doesn't know, but that's the test subject. The first 3 people answer wrong intentionally. And what happens, kind of crazily enough, is this person who's kind of the subject of the test changes their answer. They will actually think peer pressure.
Yeah.
And you mentioned, the reason I bring it up is because you talk about survival, right? Our survival is about, well, if all the humans are walking towards this water hole, I should probably follow them. So there's this kind of innate response to go along with the crowd or the herd, herd mentality. And I think that's what makes science so unique, is that it's almost on its definition rejecting the herd mentality of saying, I would much rather listen to the thought of one rational man than follow 1,000 irrational people.
It's the true democracy. If you think about
Yeah. Well, I sometimes think that comedians have some of the best insight into society.
George Carlin.
Oh, I know George Carlin.
That's why I think I listen to Joe Rogan so much. I'm like, he's always got comedians on, and they always have just an
comedians have
interesting
always
take.
been the first line of criticism of in class.
Yeah, and so I was listening actually this morning to
Or the last line, depending on how you want to think about it. If they've censored everybody else, but they let the jokers play against them. You gotta have somebody to make fun of the king.
yeah.
If you make too bad of a joke, your head's gone.
The jester, the royal jester.
Yep. So comedy has always served a very important role in dissent.
Yeah. But so this comedian I was listening to this morning, he had a really good point. Like, we've known about reasoning since the 1700s.
I'd say as far back as the Greek. You mean reasoning like logic?
Like the actual formulation of what reasoning is.
I'd say probably Greeks. Yeah.
Okay.
200 BC. Probably Pythagoras.
Well, I feel like the earliest.
But the scientific method, until
Probably
17.
Scientific method. I mean, depending on how you talk about the modern theory, the modern science. I think you have Descartes, right? I think therefore I am. The Cartesian coordinates actually tracking out, like kind of quantifying. So I'm sure there's some blurring line. Reason
either way, like if it's even further back, it makes this point even more, right? Which is, but yet so many people don't use it.
Yeah.
So it's almost as if like,
it's like that one
I
video
have it.
of Veritasium, right? He says everyone wants to be smart, but there's books everywhere, but no one's reading it. Or everyone wants to be strong, there's heavy objects everywhere.
That's funny. And then I think even Feynman had a quote. I love Feynman. He has something about, I'm not special. I just studied hard.
Passionately curious.
I got my shirt on right here.
Let's go. Einstein was always, he would say that I'm no genius. I've just spent longer with.
Well, and there's actually a really funny story. I don't know if this is true, but I think it's true. Somebody from some news source outlet was asking Einstein, said, "What's it like to be the smartest man on the planet?" Do you know what he said?
Ask Nikola Tesla, right?
That's exactly what he said.
But
ask Nikola Tesla.
I read two different reviews on that one phrase. Because
I've heard mixed.
Some people say that is a compliment, but some people say it's a backhanded insult. Because at the time, Nikola Tesla was arguing that gravity does not have to be described as space-time. It could be expressed as a part of the ether or something. And Einstein, they criticized each other a lot over letter and also publicly. So he used that as a public backhand.
I never thought about it that way.
So I was like,
it's a backhanded compliment.
It could be.
Yeah.
Or a backhanded insult.
Well, what's cool is so Dr. Brian Keating, a physicist, he has a great podcast, and one of the podcasts he just recently had was with this. I don't know if he's a physicist or like an historian, where he goes over some sort of, how would I say, like not misclassifications of Einstein, but misinterpretations. The normal misinterpretations of what Einstein said. And so it's just he gets into different things that he said about quantum mechanics that some people
even about space-time.
And so I don't know, it was just a cool podcast. I just eat up anything about Einstein.
Because the book Stubbornly Persistent Illusion is a really good read.
Persistent
I
Illusion.
heard about that. I heard about that.
Assistant illusion. So
I've only made it maybe halfway through it. I haven't read it in a long time, but
what is that about?
it's Einstein's book, but I think it's. I don't think he wrote the book. I think it's like a couple. I don't know if it's manuscripts or something, but I think it's written by somebody else. But it's on Einstein's
Name.
Yeah, well, you have it?
Oh, wait. So it is by Einstein.
Yeah, I think he wrote it, but it's like one of those books where like somebody obviously picked it up and translated it and like wrote it, gave it a preface, and yeah. So I think because there's a secondary author, but it's Einstein's work.
Secondary, it did say Stephen Hawking's the narrator.
That's what it was. It was Stephen Hawking. That's who it was. It was Stephen Hawking.
Cool.
Yeah. It's a good read. At least as far as I've gotten through it.
Yeah.
It's a biography / autobiography. So it's partially written by Einstein himself, partially talked about by someone else, like Stephen Hawking.
Yeah. Yeah, check it out. It's not too pricey.
I heard about that, and I love that.
It's got a really cool cover too. It's like gold and shiny.
Yeah.
You know, I love my shiny covers.
Yeah, there's this idea that AI, one day you're going to be able to have an AI that's like Einstein or AI that's like your favorite physicist.
Yeah.
But go ahead.
I doubt that.
But so
Yeah,
I gotta ask.
yeah.
So how do you guys feel about using AI to bring back the dead?
I don't like it. Because I think it's such a limited sample size of how they think and feel. You cannot imitate it perfectly.
Yeah. Now, if you had, for instance, some of like David Deutsch, right? He's still alive. We now have a lot of podcasts with him on it, right? We can even go and interview him, or he can even get he's got a whole book about his thoughts on different physics topics. And so then I think you could pretty well replicate him.
I think you could.
I
think you could, but should you?
I don't know. I don't.
That's the ethical question.
I don't think you should unless the person consents. But But I think even then you're not perfectly imitating.
Of course.
Because remember that in psychology there's 4 sides of you. The side of you that everyone doesn't know, the side of you that only others know, the side of you only you know, and the side of you that both others and you know.
So have you heard
perfect.
There's a summary of all of that.
Yeah.
I think I am who I think you think I am.
I heard about that.
Yeah.
We are. I guess
it's the seeing through the looking glass, right? The Alice in Wonderland. I can't remember the author of Alice in Wonderland, but that's where he came about it from. Was this idea that you're looking at yourself through the lens of how you think other people look at you?
Yes. It's a mirror.
It's a dual mirror. Yeah.
The strange thing is, this thought goes back ancient times. That like ancient Eastern
Plato's
and Western,
cave.
Ancient Eastern and Western philosophies say that we are all mirrors of each other.
Yeah.
Or there's another saying that we're all mosaic of everyone we met.
Yeah.
You know? So like
I feel that one.
Tesla even has a quote about that we're all, we all feel and think and breathe and we're all human beings.
No, which makes sense because we learn by imitation, right? The way we speak, the way we think, and even the brain, we have literally neurons called mirror neurons that fire when something happens to other people.
Huh.
So
interesting.
So mirror neurons, that's how we learn. That's how we think. And feel. Yeah, that's why when someone yawns, you yawn, or when someone changes posture to uncomfortable posture,
right? You switch too. Yeah. You take a drink, I take a drink. Right.
This is called pacing and mirroring. It's both a technique to make people build rapport in social engineering, and it's also a natural phenomenon that humans just naturally do.
Well, it's interesting you bring up social engineering. So when I was talking about systems theory and how my little idea has everything to do with systems, I wrote I don't want to say a paper, but this idea that everything is an energy system. Even social systems are energy systems. And I have this thing called social dynamics where I've been trying to kind of work on using the resistance, capacitance, inductance model to describe social phenomenon.
That would be awesome.
And I'm actually taking this from the Silent Weapons for Quiet Wars. So if you guys pull it up ever later, anybody's watching wants to go pull it up, it's on like the 6th page. It's not very far. There's this like tertiary shape, and the idea is that you can model economics the same way you can model economic. You can model economic capacitance, inductance, and resistance, and everything is this system. But what makes it challenging and kind of breaks it out of the can you apply this everywhere is whether that's a linear system or not. And so when you get outside the linear systems, you have second order effects. And so you can't always just describe it in terms of these three, you call them passive components. The resistor, the inductor, and the capacitor are usually called the passive electrical components. Diodes, transistors, these are active components, usually quantum mechanical. And I just off the side, I want to maybe just say this, I think it's funny. You've heard like be the resistance,
Yeah.
I don't know, I'm a big Star Wars Andor fan, but they talk about the resistance, the rebellion. Well, I often kind of joke, and I'm like,
The
well,
resistance.
Yeah. French resistance, rebellion, uprisings, revolution. This idea of dissent, right, kind of promotes the idea of ideological revolution. So you think about resistance as kind of this dissipator of heat energy, but rather than saying, be a resistor, be a passive component, I usually try to say be a semiconductor.
Okay.
Right? Like, don't just resist things for the sake of resisting, because it doesn't really show principle. I'm just going to resist this because I don't want to do that.
Let the things pass that you.
Let some things pass through you like a diode.
Yeah.
Let other things not.
Interesting.
Like Gandalf, this you will not pass. So don't be a resistor, be a semiconductor.
Yeah. Well, I love this idea of sort of using. I don't know, the analogy of energy.
I'll be bad in your bathroom break.
Okay, gotcha. So, like, there's this term called active inference. And I forget who exactly it was that came up with it.
Tell me more.
But so let me just read to you what it's about. So, theoretical framework for understanding sentient behavior, characterizing perception, planning, and action through probabilistic inference. It is grounded in the free energy principle, which posits that self-organizing systems like the brain minimize surprise by continuously updating internal models of the world and acting to fulfill predictions. Here it is. It was developed by Carl Friston and expanded upon by Thomas Parr, which is the guy I was listening to on the Machine Learning Street Talk podcast.
I mean, that sounds like kind of the same idea. There's this system, almost sometimes self-correcting, but not always. It needs some. It doesn't just do it on its own. It needs some feedback.
Yeah.
But that it's an active learning thing. It's not just a passive thing. So I'm glad you brought that up, because it's. I think the way I've described my model so far is it's almost just like it just happens, right? It should just happen on its own. It's like, no, it requires an agency, right? An agency, like
That's exactly what they talk about. They talk about agent.
Yep. It's all about the agency. So if I say, well, I have no power, I have no control over this, well then I'm kind of relinquishing the ability to even have an impact.
Yes.
Right? I don't have a force that I can change motion with anymore. But agency is the force, right? This whole idea, like maybe free will, if you want to think about it that way. But I have the ability to choose to be logical or illogical. Sometimes I want to be emotional. I don't want to be logical.
Yes.
If anything, we are probably more emotional beings than logical beings. But it's not to say that you shouldn't be emotional in place of being logical. And neither are they mutually exclusive.
The balance.
You have to balance it.
Yeah.
You have to choose. There's a funny. Every time I say this, I always think about a silly episode from How I Met Your Mother. Pick your battles. Where it's like you have to just pick the things that you want to tackle. And so like whenever I was working on that paper or the talk for this. For Tuesday, there were some things that I want to talk about, some things I just didn't have time, and it felt like they didn't match.
Yeah.
So it's like you just have to kind of pick what things you can, because there's some things that I'm emotional about, that I care about passionately, but they don't really matter in the logistical pedagogy of like, how does this relate to something else?
Yes.
And so that active inference is a cool idea, because you're really seeking the energy minimum state. And that's what I was saying earlier. If you have 8 different outcomes, or 8 different, not necessarily outcomes, but just 8 different ideas, or even truths, if you want to permit that they're, or just on premise say that they're all actually true.
Yeah.
Maybe within those 8 truths there are 4 underlying truths, and under those 4 there are 2, and under those 2 there could be 1. I'm not saying there is one. I'm saying that if it's a good system, the better system, will allow you to reduce the necessary initial conditions. Right? The better model I have, the less information I need to describe the model.
I just have a quick question because we talked about this before, which is like language entropy, right? How much we can, or
that's a thought.
Kolmogorov complexity and whatnot. How much we can compress information without losing its fidelity and its depth.
I'm glad you used the word fidelity. Yeah.
So like if there is a unified description for anything that you can do, so like a unified truth that you can derive everything else from it, how do you think it would be like? Would it be a single statement? Would it be a page of equations like the Lagrangian? And
that nasty looking equation.
Oh yeah, that's terrible.
Yeah, no, I think I have to think about that because you made a good point earlier. Is it qualitative? Is it quantitative? Is it both? Is it neither?
I think it's both.
I think it's both.
How much can you compress truth?
No, that's
is
a
it
good
42,
point.
You know?
Yeah. There's a point, and I think even in ethical skeptics work that I've referenced. You brought up Karl Popper. There's a Popper demarcation line. There's falsification and deduction. Under that is induction. And so once I move down below the inferential power of deduction, 100%. Falsification 100%, deduction 95%. I move into inference. I move into induction. I'm sorry, I said that twice. In induction, you have kind of just consilient information. So Karl Popper is like kind of treating that like, if it's not falsifiable or deductive, it could be, but it might not necessarily be. And so there's a level where I can only simplify so far. Even Einstein has a quote that says, "Only simplify as much as possible, no further." Because if you take it too far, you'll lose it. Well, you'll lose it. But I think Ethical Skeptic has a quote that takes it even farther. Once you simplify an idea for the masses, good luck getting it back. Because if you simplify something too far and then everybody takes it and runs, the truth is still putting its shoes on by the time that lie, that fallacy is made all the way around the world.
I think that's the trouble, right? For example, like,
how do you stop that?
Yeah.
I have no idea.
Because there's a lot of misunderstanding and myths that need to be clarified in both history and science and pop science, right? For example, time travel, Einstein's idea of space-time.
Or quantum in general.
Yes.
Yeah.
If you read the stubborn illusion, the stubborn persistent illusion or something, that book that you just said, they will mention there is a part, if I'm not mistaken, that Einstein describes that time is an illusion, a construct. It's a construct that we use to describe systems, just like how in math we have axes,
right?
And in kinematics we have position and then time, right? To trace out a trajectory, right? Yeah. But the time itself is not something you can go back and forth to. It's just a useful measure.
Right.
So it's a dimension in the sense that it's an axis. It's not a dimension in the sense that it's a
physical thing.
Dimension.
Yeah, there's no time ruler.
It would be saying like, a momentum space is physical.
It's a phase space.
It's a phase space, it's a possibility.
Right.
So.
Right. But the idea of oversimplifying, right? If you take something and simplify it too much, then you may never get it back.
Yeah.
And then you're spending more time, and I think this is something that the ethical skeptic mentions is that science communicators sometimes run into a problem of them trying to actually simplify things too much, so that it's like explain like I'm 5. No, like we should stop that.
Yes.
Like there's a point where
the complexity is beautiful.
And I think I don't know if it was Sagan or Feynman who said this, and ethical skeptic kind of clapped back and said, no, like if you can't explain it in simpler terms, you don't understand it. I don't know if that was Feynman or Sagan.
That's Feynman.
I think it was
Sagan
Feynman.
Quoting Feynman.
Yes, so Sagan quotes Feynman, and ethical skeptics like, no. Because if you do that, it doesn't necessarily mean you understand it. It means you oversimplified it so that somebody who doesn't understand it can try to. Well, there's a difference between comprehension and understanding.
Yeah, which is why I think quantum mechanics is having a lot of that problem.
Yeah, well, I remember when I was like 5 or 8 or 6 years old, whatever, I got this thing called the quantum leap, the little quantum leap pad learning frog, and it's the quantum, it's almost been so popularized that it's like, it's almost ephemeral. It's a buzzword. And I'm going to give you as an analogy real quick, because there's this idea of comprehension versus understanding. And there's 3 tiers to what ethical skeptic calls the 3 experts. And I think I have an idea. Before I read his thing, I had a friend, the guy that went to our church. His name's Blake. He did magic tricks for our church. It's super cool. So growing up, my dad being the youth minister, I spent a lot of time with Blake, wanting to know how the magic tricks worked. Of course, right? I'm like the science-minded kid who's like, yeah, okay, you can fool me with your hands, but like something's happening, right? So in terms of this analogy of the three experts. Level 1 experts, usually called, as ethical skeptic calls it, the bowel movement expert, right? Everybody knows how their bowels work. You know, it's called trivial knowledge. It's like, well, the sky's blue. Yeah, but at the same time, the sky's actually brown or red or orange. But the idea is it's a trivial level of knowledge. So in the magician example, consider that it's a magic trick. And I say, well, it's a magic trick. And everybody goes, well, of course it's a magic trick. So that's level 1 expert, being able to identify that it's a magic trick. Level 2 expert is understanding. By being able to, let's just say I'm a magician, I show you how I did the trick. Now you understand the trick.
But you can't do it.
But you can't replicate it. That is comprehension.
That is the third.
That's level 3.
I see.
And so level 3 expert is where you've not only understood it,
You can
demonstrate
It's
it.
like what you said.
Exactly.
Demonstration.
Precisely.
Wow.
So it's all about moving from level 1 of like, well, yeah, the sky's blue, or yeah, it's a magic trick, to
Why?
I can show you how this
Why it's
works.
blue, yeah.
Really scattering. type of
Exactly.
thing. So
Yeah.
you show them. Oh wow. That's
Correct.
crazy.
Yeah.
That's interesting. Do you I mean, I don't know. This is just something I just thought of, right? Jupiter brain. And so, do you think that there is maybe something in common with elusive truths?
Yeah. I mean, just. I think what's weird about it though is I think history is told by the victors, and I think there are some things that will never be uncovered. Like even if we could do all the archaeological digs, we could do all the LiDAR mapping of all there's all these things that we could possibly do to make measurements, and I think there are some things that doesn't matter how precise our tools get, how advanced we become. Some things are lost, completely lost to history.
I think a better way to put it is victors written by the survivors.
Survivors, yes, yeah.
Because even if you
you might lose,
even if you won the war, there are people there that will be spreading their
even the counter tale, right?
The counter tales.
Yeah, right.
The only thing I can think of off the top of my head, what is the commonality between these elusive truths is time, right?
I would agree with that. For me, it was history, but some things get so far away. Crossfade, so far away. Anybody look Crossfade? Good song, good band. So far away. Anyway, but some
I know
things
Mike's in front of you making someone sing sometimes.
I grew up. Crossfade was the first CD I ever had. It was given to me in 6th grade. This guy named Kyle. We were in school. He gave me Crossfade on a CD.
Nice.
So anyway, but yeah, I think time is just at some point you get so far away from something that there really is no way to go back and reconfigure it. I mean, I think you could say even Göbekli Tepe. Like even if we could do all the digging and figure everything out, I still think and not to say that we shouldn't try.
Yeah.
There are just something.
Oh wow, you were going back in time. I'm thinking further in time.
Even though, let me take this then. So let's just say this is incredibly hypothetical. Let's say in 50 years, there's some global cataclysm and everything gets wiped out. Whether it's an X flare, who knows, some kind of thing happens. And in 1,000 years, they're looking back at our technology, and the only thing that survives is some, stones and some bricks and some tools. None of the satellites are still alive. Everything, whatever. They're going to try to reconstruct their perception of what we were trying to do. So you're stacking lots of. It's stacked provisional knowledge. It's like, they must have all been hunter-gatherers. They were all nomads, and now they built tools, and now they did this, and you come to find out that, wait, maybe they actually were settled long before we ever thought that they could have done that.
It's just that the tools that were left behind that we can find is primitive, right?
It was primitive, but that doesn't mean that they didn't have other tools. Yes, and
because
so for
advanced tools are more fragile, for example.
Yeah, and so that's where for me it's almost a little haunting to think that we really are here for just such a small amount of time.
Yeah.
That actually makes sense if you think about it. For example, let's just imagine, touch wood, if this entire library just burns down right now, okay, what would be most likely left behind?
the foundation. I mean,
Yeah.
Not the technology, not the books,
Not the plastic.
It's only the primitive brick and wooden stuff that's left behind, you know, the unburnt wood or like the ashes and the foundation.
Well, and even if anything, let's just say sufficiently advanced. There's the great quote. If I say sufficiently advanced, I have to say the quote. Arthur C. Clarke: "Any sufficiently advanced technology is indistinguishable from magic." And so when I'm talking about this idea of magic, right? Level 3 experts says, I know this is a magic trick. I know how to replicate it. It is no longer sufficiently advanced. If I took my cell phone back to the 1800s, it would be magic because they couldn't comprehend it. I could show you, here's how it works. Touch the buttons, make a call somebody. They still think it's magic.
Light them on fire.
Yeah. And so I think that's where there's just time, right? There's the level of sufficiently advanced, sufficiently advancement that after so much time, after science changes, there's just so many iterations that trying to go back or even going forward that we are almost doomed to lose information just by entropy. There will be some things that just get lost to time.
It's crazy because think about how far we've transitioned, right? Back in the day, when people have limited understanding of meteorology or like astronomy, right? Like a lightning storm or a meteor shower would be enough
sign
reason,
from the gods.
Yeah, it would be sign from the gods or enough reason to burn a woman on a stake and type thing. Like that's a quote I'm referencing from Carl Sagan, but like that's just a few hundred years ago.
Yeah.
It's crazy.
And the first discovered asteroid was in like the 17 or 1800s. And so, but my question there is like, how do you discover an asteroid? Or is it just, and maybe I just need to look deeper into this, like, did he just say, I discovered this asteroid?
It's
like,
a rock.
What?
Yeah.
Is it just like he knew what it was?
Well, when you guys talked about the scientific method, right, you started with observation, not with hypothesis. So it always starts with observation. So if I'm Galileo, I'm looking at some telescope and there's this moon, this Ganymede right around Jupiter, I'm like, what the heck is that? Like, there's moons on this thing? I'm going to start like tracking them. I'm going to start drawing pictures. He didn't do any, as far as I understand, Galileo didn't do any quantitative analysis of the planets. He just sketched them qualitatively. It was Tycho Brahe who did the mathematical numbers that went along with it that Kepler later turned into his laws of planetary motion. So I think what maybe kind of with all the points that we've been making, it's a continuous iterative process, right? And unfortunately, it's like we as humans just don't seem to live long enough, or maybe it's actually to the fact that we live as long as we do, that it isn't until somebody dies or an idea dies with them that progress can be really made, because the paradigm has to change. And so there's social factors, political factors, lots of things that go into kind of substantiating a status quo. And it takes a lot to overcome that. I mean, think about like you guys know about gravitational potential wells. So if I had something in a potential well and I want to kick it out to another level, I have to apply enough energy to get it out of that state, that ground state.
Tunnel.
Or quantum tunneling. Literally talking about diodes, be a semiconductor. If I apply what is like 1.5 volts to a reverse bias diode, it'll actually flow in the opposite direction.
Yes.
The electrons, as they quote unquote flow, they tunnel through this barrier in reverse bias, given sufficient voltage. But in order for the system, the paradigm to change, it needs a rude awakening. It needs enough energy to kick it out of its original threshold. And that's the punch, that's the force, that's the kick of like
that's so interesting.
the dog chasing its tail, and I say, stop, like look at your tail, you're just chasing the same thing, go over here.
That's so and I don't know, for some reason it seems like there's so many people that are now, I guess, adding to the scientific
just the body of science.
There's the body of science, that it seems like it wouldn't make sense that there's still a gatekeeper.
Yeah, maybe, but you could also argue from the opposite perspective, maybe that's actually why there's more. because there's just so many more people that it's almost like it's too big of a club now. That like it's harder for the normies to get in.
Yeah, I've heard about that with string theory. Like, there's so many people
Well,
focused
there's
on
a
string
whole
theory
rabbit
right
hole
now.
about, and I don't know that this is true. I think Eric Weinstein was the one talking about this. That there was a kind of a gag order from the military. If I'm speaking maybe out of turn, but you look at what Eric Weinstein says about this. He talks about how there was supposedly a gag order in like the early 1900s, like basically around World War I, where it was like, well, we've kind of maxed out science. We need to kind of get everybody talking about these weird things that don't really matter, like string theories. I said not that they don't really matter, but things that can kind of keep everybody occupied, playing in these little toy models, not actually doing real science, because they've kind of, I don't want to say dominated, but they have a embargo on what can be discussed.
The government? Is that what you're saying?
The political power. I don't want to say like the American government, but just the governing elite of the world
Interesting.
have a vested interest in keeping those secrets safe.
Yeah.
So if there's
sense,
Nikola Tesla invented
grants, right?
right. Well, if Nikola Tesla invented the rail gun, and then you find out his lab was burned down, some people say, some people say J.P. Morgan had something to do with it.
Yeah, I've heard of that.
Yeah, it's like, okay, well,
Chase.
if he had invented this railgun, and then 100 years later, the U.S. military has a railgun that's based on the documents that they literally took from his lab, it makes you wonder, like, well, how long has that stuff been in the black site for? Yeah. And what do they have now? I mean,
Free
there's all this stuff about
electricity.
UFOs are being released, like all the videos about, we have all these things now, whatever.
That's
it's
just
like,
what they
how
want to release, right?
I guess kind of that's where I'm going, is like, it's not to say that like science is at a standstill, or that Eric Weinstein was saying that science is being like at a gate kept, but like there does seem to be some kind of
Fishy stuff,
because we're almost kind of stuck in a loop of just dancing around these multiverse and string theory and M theory and all these different things, and it's like nobody's really doing any real measurement science anymore. Yeah. It's like, well, we've got the CERN, and it's like, it's the largest, most funded research project on the planet.
Yeah.
And what's really come of it?
Yeah.
And I don't mean that like in a bad way. Sure. But like I know whenever Dr. Wilson, he was a high energy particle physics, or did some high energy particle physics, that it almost feels like they're just kind of adding and stacking knowledge based on assumptions, and they're not really converging on a better model. They're just kind of appending the existing model, which could introduce more fallacy.
Did you find anything else on the asteroid discovery?
Oh,
Series, I believe, is the name of the.
So
You're not talking about the one that's like coming through and they think it's a spaceship, right?
No.
You know what I'm talking about? That
Yes,
weird
yeah.
one? Yeah.
No, this is the one that was the first discovered asteroid.
So in 1766, Johann Daniel Titius
Okay.
noticed a mathematical pattern in spacing of the planets, and he was is later on called as the Titius-Bode law. And they found that there should be a planet between Jupiter and Mars, and they don't, at least based on the spacing, but they don't know what it would be.
Oh,
And
that's the
based on the
asteroid
same
belt.
law, they predicted the existence of Uranus, right? So in 1800s, a group of astronomers called the Celestial Police, which is kind of cool.
Space Force.
Yes, organized by Franz Xavier von Zach, I don't know if I'm pronouncing this correctly, began systematic search of missing planets. And by accident, they discovered, on January 1st, 1801, Italian astronomer Giuseppe Piazzi, the one we talked about,
Yes.
discovered a moving object in a region of the sky. He named it Ceres, which is thought to be the missing planet, but turns out it's just one of many asteroids and dwarf planets in the asteroid belt.
Okay, there we go. That makes sense. Yeah, we sounds tedious.
There's this whole thing about why the asteroid belt is where it is and why Jupiter is so big, and now it's almost as though Jupiter is actually serving as a protector of Earth, because it
Yes, I've
pulls
heard
in
this, yeah.
things that would otherwise perhaps collide with Earth.
Which I'm just curious, right?
It's like a binary star system almost, just without Jupiter being a star.
Because based on what the evidence we have, apparently, is that there was at some point a planet, a dwarf planet called Theia that crashed into the proto-Earth, and it created a ring. That ring became the moon. Now, my question is, right? Why doesn't the asteroids clash and clump up to become a big enough planet? Why did they all just stay scattered?
That's a good question. I don't know.
Oh. Yeah.
My microphone finally hit some entropy, I guess. I don't know.
I don't know why the asteroid belts all stay. The asteroids. I can't remember. I remember reading something a long time ago, and I won't act like I remember what I said. What I read.
Because from what I know is, it's, you know how in a lot of sci-fi movies, at least early on, if you travel into the asteroid belt, they're like, you gotta crash in the.
Yeah.
They're so far apart.
They're so far apart, you can go straight through the asteroid belt, and you probably won't hit.
Dude, you blew my mind when you told me this. I went and told my girlfriend. I was like, "Can you believe this?"
Well, it's like when you watch The Empire Strikes Back when they're flying the Millennium Falcon through the asteroid belt. Yeah. Great soundtrack on that scene, by the way.
To be fair, the Millennium Falcon is huge.
Right.
So
it was hitting some of those asteroids.
Yeah. I mean,
I think they lost a dish or something.
yeah, but still, but like still though, like why are they so sparse?
That's a good question. Yeah, I
Why
don't know.
aren't they colliding to become and clumping up? And for example, the same thing in Saturn, right? The rings is so big. Why aren't they clumping up? Even if they are, why are they?
Yeah, it's weird. There's
tiny
enough
moons?
gravity to keep them in sort of close together, but at the same time, not enough to keep them.
Yeah, I was gonna say, I almost wonder if it's just a matter of time scale. Like we've only been looking at them for so long that, like, if you watched it in 1,000 years, maybe they would actually
clump up.
Yeah.
And I know for a fact that for sun moon systems is that if the moon gets too big and too close, it will start tidal forces will start ripping it apart again, and it'll go back to asteroids again. So like, or it'll crash into the planet. But so I'm thinking like, is it like what you said? Is it like too little time, or is it too much time that there was a planet just got ripped apart
beforehand.
again?
Yeah, that's a good thought. I don't know. No, what is crazy? This blows my mind because I find talking about geometry.
Yeah.
Did you guys know that the planets can also be represented as a Fibonacci sequence? The spacing of the planets.
Yes.
I didn't know that.
Look that up. That blew my mind. That again, yes, the planets themselves are roughly spaced.
Universes, or not universe,
Spiral galaxies.
galaxies.
Yep.
Spiral galaxies.
Yep.
Yeah.
Yep.
Or is
Fibonacci sequence.
Yeah.
It's uncanny to me. So for me, when I remember Dr. Teo was like, well, so like, what is truth? And I'm like, I don't know. But geometry seems to point to it.
Yeah.
Because, and I'm not to sound like some Pythagorean cultist.
Yeah.
But yeah, I think that if there's some Fibonacci sequence, that there's got to be some inherent truth to that sequence.
Well, and then to me, it's weird because it kind of.
I guess
I don't know how I want to say this, but
nature's constant, I guess.
because we've talked about it
golden
before.
rule.
It's sort of
The golden ratio, I mean.
Yeah.
you sort of get to creationist theories and things like, because it's like it feels sort of designed,
Well, I wouldn't count it out.
you know, and I don't know how to think of that, you know.
Another weird one, just to give you guys some interesting proportions. You know about the volumetric to surface area proportion with
The
animals?
Scrooge law.
Yep.
Of the,
There's a reason why, there's a reason why elephants are absolutely gigantic and have a huge weight and big old feet. And ants have teeny tiny little feet, but they're super strong because there's a certain ratio of their volume to their surface area. And humans are
one of the perfect end.
Well, that's what
Perfect. Huh?
Leonardo da Vinci claimed, right? The Vitruvian Man, right? That we are the perfectly proportioned creature. And that to me that speaks a lot.
Which also is coincidental because if you're too big, your brain has to work more to maintain the body.
Even people who are like 7 feet tall have problems with their heart and breathing because their body can't pump oxygen as well.
Yes, and also your brain takes more power maintaining the body. That's why they found that most intelligent animals have brain-to-body ratios that are high. Of course, they were not talking about density because birds are a different case. But again, like complex social animals, even ants, they have high brain-to-body ratios. Elephants and whales, they have big brains, but because of their low brain to body ratio, more of their brain is actually used to like maintain homeostasis. They're still intelligent.
Homeostasis,
They're still intelligent, but they're not, to a point where they can solve equations.
I wonder if there's also like a gut to brain interesting ratio there.
Gut to brain so the brain gut axis is proven that our brain and our gut communicate.
Well, and there's this. It's called candida. It's like a yeast that gets in your stomach. It's built by sugars, and it will actually convince your brain to eat more sugar.
And it will also increase the amount of hormones of ghrelin, which is the fat storing lipid that makes you hungry.
Yeah, the gut is to me it is so fascinating.
Gut feeling, eh?
Yeah. There's this. I think there's the book is called Gut that I read a while back that just talks about why you need to really be healthy, eat healthily, because it all
affects
depends
your brain, your brain chemistry,
and also like how you feel about things and your psychology.
I have a bigger thing that will blow your mind.
Okay, go ahead.
Every major planet in our solar system can be fit in the orbit between Earth and Moon. All of it. You can line them up in a straight line, and they can fit.
Between the Earth and the Moon?
Yeah, between the Earth and the Moon.
All the planets in our solar system. Not major planets, the 8.
So if you just lined them up edge to edge, they'd all fit.
Yeah, they'll fit in. Well, not perfectly, but you get what I mean.
Yeah. Well, I mean, because and that's what I was saying too with the Fibonacci sequence. Like, if you look at the spacing of the planets, it's pretty damn close. Like, I've got the spreadsheets, but you can do their, because of course the orbitals are ellipses, so they're not perfectly circular, but on average. The other thing that also is kind of interesting, kind of as a side note, we're talking about the solar system. Just regurgitating some cool little facts. The center of the solar system sometimes actually leaves the sun. So, like, the mass center of the center of mass of the solar system is often outside of the sun itself. It's actually just a little bit outside. I think probably 60% of the time. I think it's 60% of the time it's within, 40% of the time it's without. So the center of the solar system isn't exactly the sun. It's a little outside of it sometimes.
That makes sense. It's like a binary system. The center of mass is not in this.
And Jupiter is heavy.
So weird.
And Neptune and Uranus. I mean, there's so many big things on the outside too.
Dragging it around, man.
Yeah.
That's why, we've had 2 episodes now on cosmology.
Yes.
And that's what I love about this podcast is it forces us to go down these rabbit holes. What I wouldn't say forces me to, because I love it at the same time.
Encourages you.
Yeah. And I've always been fascinated with the stars, but I didn't realize how fascinated I am and how interesting they are to me until we started doing those episodes.
The next episode about stars, you'll be blown away.
Yeah, I'm excited because it's just there's like an infinite amount of things, and then there's also still a lot of things we don't know.
Oh yeah.
And
that's what I wanted when I was doing my physics degree, because I switched from mechanical, thinking, physics is a bigger field, no pun intended, because space. But like, there's almost, I'll be honest, it's almost intimidating, cosmology.
Yeah.
It's so vast. Like, it's like peering into the deep ocean.
But now there's
we know more about space than we know about our oceans. So for me, maybe on another side of things, I'm actually interested somewhat more. Like, what's going on in our oceans?
Yeah, of course.
Because, like, right under our
It's
feet.
muddy waters.
Yeah. Talk about a deep one. Yeah, there's some.
Yeah, and that's what kind of like
The pressure makes that challenging.
I always get excited when somebody's like, "We built a submarine to go to the bottom of the ocean." I'm like, "Let's go!" And then they.
Well, the Mariana Trench, the Challenger Deep, there have been real manned surveys there.
Yeah.
It's just that they are legit submarines. They're not some carbon
hobby.
fiber.
Yeah.
People even warned that guy.
Yeah,
But
that's it was really
tragic.
sad. Really sad. So I don't know. We're getting close to like 2, and we're like I think past 2.5 hours now.
Did you have any questions for me about the talk? So you were gonna. I think you had maybe some student questions. Did anybody give you any?
Oh yeah, I need to look at that. I had asked a couple of people too, and I don't know if we ended up getting questions.
Well, I'm happy to answer any.
While you're looking at it, I have questions because you know how like Gödel's incompleteness theorem and like
You brought that up, and at the talk somebody brought it up too.
Yeah.
Yeah. Somebody asked me about it.
basically, because I'm sorry I couldn't make it to talk. I have some
No, it's
prior
all right.
commitments.
Yeah, yeah.
I really wanted to go to the talk.
You can watch
but-
it.
Yeah, I can
It's-
watch it. I'm looking forward to that. But basically, it's like what you said, because inferential dynamics, right? So there are some stuff we have to infer. We cannot formally.
Yeah.
In a weird way, formally we are, but Gödel's incompleteness theorems and other incompleteness theorems like undecidability or incomputability or halting problem, right? These are all proofs that logical systems itself have a limit. So do you think that at the end of the day we'll never be able to create a method or logical method to be able to deduce things, I wouldn't say perfectly, but close to perfect? Because math itself cannot prove math. That's
Right.
Gödel's, right? Undecidability, they've been proved that there are certain systems that we just cannot, using data, we cannot use machine learning, we cannot use just pure algorithms to decide whether or not this will or this will not happen. That's undecidability. And incomputability just says we cannot simulate certain things. We cannot compute it.
Yeah.
Yeah, so what are your thoughts on that?
Well, the answer that I gave, because somebody asked me the same thing, and I'm only vaguely familiar with the incompleteness theorem, but the idea that there is kind of a fundamental limit to what we can
Using formal
know or even measure. I referenced Heisenberg's uncertainty principle, right? There are limits to how well or precise we can know position and momentum. We can't know both completely. I can know some of one and some of the other. The example that I used is that if you're walking your dog around a neighborhood, let's say there's a fence, I could stop and look through the slit of the fence and get a very precise and kind of small sliver of what's going on in the backyard. Or I could walk and get kind of momentary accurate glimpses of the full backyard, right? By moving. I can either stop and look at a very small sliver precisely, or I can move and get a imprecise but accurate view. And there's always an exchange between accuracy and precision. And you can never be fully precise and 100% accurate. You can either be accurate or precise, but you cannot be 100% of either. And so the idea with kind of what I proposed is that you would converge on a limit. I don't know what the limit is. If that limit is delta x, delta p is greater than or equal to h bar over 2. If that's the case, then that's the case.
So
I don't have a quantified number for that limit, but I do believe that there is one, and that's what I called epistemological humility.
Yeah,
so that there are
that's
some
the
things we
limit
can't
of-
know. Yeah.
So do you think we're close, or do you think we're still far off?
Oh, we're
from the
incredibly
epistem-
far away.
Okay, good. That's comforting.
Yeah, no, I think if anything, the idea is that it's a relentless. I mean, I'm not even wearing my gym clothes right now, but there's a fitness apparel brand called ASRV, and they have their motto is "Only those who risk are free." And they,
fucking love that.
yeah, only those who risk are free. So if you don't take risks, there's nothing to gain, right? So make a risky hypothesis. If I say, well, the sky is blue, well, it's not very risky, right? But
It's a low-hanging
if I
fruit.
say the sky, exactly. If I say the sky is orange, well, only certain times of the day can I make that demonstration. Although it's not really even a good hypothesis, it's more of an observation. But the idea is that under their kind of motto, it's relentless pursuit. Right, it is an endless journey that you will never end. I mentioned Zeno's paradox as well to kind of go along with that. If I were to go a half of a step and a half of a step and a half of a step, I will approach the other side of the bridge, but I will never get there.
Asymptotically.
Yes. Yep. Exactly. And so I think that's kind of my
stance.
My stance. And you mentioned fidelity earlier.
Yeah.
But you were talking about trying to like make measurements and like what is this? How can I use this? My kind of working motto, there's Whataburger, just like you like it. Everybody's got their thing. My motto, I guess, right now for this, and before we wrap up, I want to make sure I mention my website. It's not perfect, it's not running, but it's up, and I want to put this talk out there. But my kind of handle is Pyrastes, the one who applies pyrastics. But the motto is probing the fidelity of nature and reason. Right? Because nature itself has fidelity. And just to kind of give you a glimpse as to why I even thought about this in the first place, the trees are starting to shed their leaves, right?
Yep.
And I remember growing up watching the cathode ray tube televisions turn into plasmas, turn into 1080p's, 1080i's, 1080 whatever.
Yeah.
Right? 4K, 10K, all the stuff. And I remember thinking, well, are we ever, and this is relevant with AI, are we ever going to be able to simulate or generate a simulation or reality that is, or simulate or generate anything that is close to reality, right? Because there will always be an approximation. So when I watch the trees, you know, all their little leaves flowing in the wind and the grass blowing and the leaves falling.
So will we have a matrix?
Will we ever be able to get a system like a matrix where I can generate or simulate the fidelity of nature to its same?
Indistinguishable to reality.
It will never happen, as far as I care. That's my claim, and I will happily die on that hill. But the idea is that my hypothesis is about probing the fidelity of nature and reason.
Because theoretically, at least based on our best scientific and calculations, people have theorized that if you do build a Jupiter brain, the theoretical limit of a computer, right?
Yeah.
So technically, you can simulate, at least to an extent, a large chunk of the universe to
indistinguishable precision.
At least theoretically.
Yeah.
So, but do you think we'll ever get there?
The only way I think
more like an engineering
it'd be like a type 1, type 2 civilization problem, where it's like, do we ever? Well, one, is it physically feasible? Like, do we have the resources, the energy to do it? Two, do we have the social coherence to do it?
And do we want to do it?
Well, maybe it's a good place to kind of wrap up, because we were talking about this. Well, what happens if some Noah's flood or something? How would you get all these people to build a giant pyramid? A giant ark, to tell them that there's something imminent coming and they need to work together. So the only way we could develop a type 1 civilization, to me, is that if there's something humanity must do, right? Not so like we said, quote et fieri, something must be done.
Necessity.
Something must be done. We have to solve this problem. We have to work together. We have to put aside our differences. That's the only way we could ever achieve something on that scale.
The end of human.
Well, it's the Ouroboros, right? The snake eating its tail. It's like as soon as the end comes, the beginning begins.
There's a quote, right? Necessity is the mother of invention. We need to prove necessity.
Yes.
So that people will want to do it.
Yep.
So what do you think is the next necessity? Because right now, there are still people denying the fact that climate change is a thing. There are people denying the fact that... there are vaccine deniers, but I don't know how much there are nowadays. But like, there are still people denying science, for example. They say science is not necessary. We can just live back in the Amish days where like we just live in villages and help each other. Yeah. So what are your thoughts on that? How do we circumvent this
without getting into an entire another podcast, my first knee-jerk reaction is I've been called a science denier myself. So anytime that word gets deployed, I cringe a little bit, just because it can be used as a weapon or a technique of dismissing critique. So without getting into the whole thing, something with climate, clearly the climate changes. And clearly humans have an impact on our climate, right? Now, how much of that is, I think, up for debate. Are we the principal cause of climate change? Are we a significant contributor? Are we a majority, a minority? What's the one that's in the middle that's not a majority, but a plurality, right? So what is the magnitude of our impact? And can we even measure that? But to your point, right, not to dismiss the idea that there are people out there who just, for any reason, no matter whether they want to, Yuri Bezmenov, a defector from the KGB, great, if anybody wants to look up something really cool, his name's Yuri Bezmenov, went by Thomas Schumann before he, revealed his name. I mentioned that you can show evidence to somebody, and if they're demoralized, it doesn't matter how much evidence you present them, they will never believe it. And so I think I'm at the point, if there are people that would deny, right, just because the people who would deny the antecedent, just say, well, no, I can't help those people. There's nothing I can do. There's nothing I can show them. There's nothing I can say. And I certainly won't force them, right, to change their mind. So I have to just kind of let those people be ignorant. And I don't know if it was Socrates who said, but there's nothing more sinful than ignorance. Right, it's like you can't. And I'm probably butchering the quote. I don't think it's exactly that crude or crass. But the idea is just be willing to change your mind. I think that's the number one thing I can say. Because there are people out there who, no matter what science or medicine is going to provide. I mean, just for example, my great grandma Rose, she never went to the hospital. She gave birth to like 12 children on a farm. Like, was never going to go to the doctor. So somebody would probably call her like an anti-vaxxer, but it's like I don't think she was like against vaccines being useful. It's just she didn't need them for her little world, little circle of the world. But then the same thing with climate, right? It's like, well, somebody's going to come in and say, well, oh, you breathe too much carbon. You got to have you got to write a tax write-off so you can. That to me is almost where it becomes political.
Yeah.
Science becomes politicized, and I think what I'm trying to avoid here is the politicization of it. Because for me, what actually makes science so great is that not that what makes it so great, but what could make it so great is that by being critical, falsifying, and deductive, you're almost avoiding it being politicized, because no political entity could resist it being falsified. Because like you said, let's just say we have this theory or this political theory or whatever it is, and there's this one example, right? I don't care how wonderful your political ideology is or whatever scientific hypothesis you have. If I can come up with one falsifying example, out the window. And it's the ability to pivot and say, okay, my idea was wrong. Let's go to the next one. But if you get wrapped up in, I got to defend my idea, I got to keep fighting for it and come up with these abductive reasons why I can still think it might be true, we're wasting time.
Yeah. I think that's a good way to end it.
Yep.
Cool.
I think so too.
All right. Well, until
next time.
all right.
Until next time. See ya.